Did you jam on? Testing 1 2 3, testing 1 2 3. Separate wait, guys. Testing 1 2 3. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is Dict. Episode 3 here of Season 3, Intro to Python. This is a separate series from our new series, where throughout the week we are hopefully going to be trying to develop a JRPG of our own on the channel over the long term, like a real-ass JRPG. But in this case, we're looking more at beginning programming concepts as it relates to Python in particular, but mostly just in general, beginning programming concepts. And we're kind of using this very, very simple JRPG as a vessel to look at various examples of how we can use all this cool stuff we're learning. Right. So before the chat started, though, before the stream started, I was talking with my friends about high school and our respective worst subjects and our best subjects. And of a list of 3 that were given, a lot of us chose history as our worst subject. But I know that Here Goes Nothing is a big fan of history. Oh, Seraph says, been working on another theme. This one's a bit more emotional. Okay. Yeah, Austin's going to be helping us with the music for our game, among some other people. Yo, there was no stream yesterday, dude. Dude, I was in some shit yesterday. I don't think I even want to talk about it. I'll probably talk about it later, during Minecraft. Yeah, there wasn't one yesterday, yeah. A Signop says, I've never... Oh, you missed the stream. I gotcha. Yeah, welcome back, Swirly Glass. We all missed you too, dude. Six says, I've never played as Mario in Super Smash Bros. My mains is 64. Where Link, Melee Link, Brawl Pikachu, and Wii U with Lucario. Okay. History's easy when you don't have a test right after. You just finished your study guide and don't have time to study. I gotcha. Yeah, it's just history never really appealed to me as a subject anyway. So, before we get too involved, I need to, for one thing, move my mouse over. 1 second, guys. I have 2 PCs here. One that I actually do the programming on, the one that handles the stream. And I gotta kind of move the mouse back and forth, mouse and keyboard, between them. You guys know the dill. Yeah, school isn't that bad. So let's see here. I think the keyboard's working fine. Good. Let's run this game and see what the game is like right now. It's starting to come back to me. Sorry, guys. I'm so excited, man. I couldn't stream at all yesterday. To say that, you know, it feels weird to not stream. When you've been streaming 40 hours a week for 2 years, it feels really weird to not stream. It's just good to be back. Okay, so let's see here. So it starts off asking us what our name is. I'm going to be Here Goes Nothing. And the monster's going to be Task Force Faust, obviously. Big Bad... I'm going to take that back. I'm going to call this guy Big Bad Faust. Right? 'Cause he's a Trogdor. Oh, we have items. I forgot about that. That's kind of cool, right? So we talked about arrays last... Not arrays. I've been using this stupid C-types library lately, where it converts the language of C, its types, to Python. They have arrays there. Now, we have lists in Python. And it's pretty cool, right? We've been adding things and removing things from this list and searching for things in that list. So we have a player inventory now. And in our inventory, we can have certain kinds of items. And if we were to use the item command here, it lists what we're carrying. Right? We've got a spear, a roll of toilet paper, a potion, and a thumb drive in our character inventory, right? We can choose what we want to use now. That's kind of sick. And if we use something, it gets removed from that list in our inventory, and it's not available for the next turn. So I'm going to throw the spear in the very first turn. Boom. So it says, Here Goes Nothing 9 hurled a badass spear at Big Bad Faust. Big Bad Faust lost a lot of health. He started off with 20 health, and he's only got 8 left. That's crazy, right? Only has 8 left. Big Bad Faust burninated Here Goes Nothing 9. He's like a Trogdor, basically. And Here Goes lost a 3 health from the burnination. That's pretty weak. We should probably change the balance this a little bit, right? We should give the monster more attack power. So now we can choose another item. If we go here, you can see that we don't have the spear anymore. We just used it up, right? Let's go look at our code real quick. As a quick little review. Oh, I remember now. The code's getting kind of massive, right? We're going to talk tonight about how to simplify this code using more advanced programming concepts. Right? You'd think that more advanced concepts make the code more complicated, right? But it's totally the opposite, right? It's the opposite. The more you learn about programming, the neater and easier to read your code becomes. So yeah, we're getting a little bit long in the tooth here. But let's go up here to our spear, right? So if we chose item as our turn option, then we list every item we have using a for loop. The for loop goes through our list of inventory and does something for each item, right? So it goes through the list, and for every item in that list, it prints it off, basically, right? It tells us what it is. That's cool. Then we get asked here what we want to use. If we want to use a spear, it says, hey, listen, if the spear is in the player inventory, then reduce the monster's health and remove the spear. Right, cool. But where's the code to tell the game to print off that message about throwing a badass spear? That's weird. But anyway, wait, is this a function up here? Oh, we have a function up here for use spear. Okay, I got you. I'm sorry, I'm stupid. Yeah, so we were kind of introduced the idea of functions last time as well. So the monster's health is reduced by this function, use spear. Right, so use spear returns a new health for the monster, and it needs a few arguments like the protagonist's name to do its job, the protagonist's health, the protagonist HP, attack power, monster name, monster HP. And then we remove the spear. Right, when we run this function here to get the new value of the monster's health, it calls this function up here, where we defined use spear. We defined it as requiring all these arguments that we supplied down there. It reduces the monster's health. It turns this health to a string so we can print it off. We have a little string here, throws a badass spear at so-and-so. It's kind of cool. Let's see what I'm missing in the chat here. American history is fucked up. It's just white men have ruined everything. Yeah, Big Bad is kind of a misnomer. Yeah, he's not doing a whole lot of health. But why don't we fix that right now, in fact? Let's give the monster a little more attack power. He's kind of fucked up. He only has 3 attack power right now. Let's give him, like, 6. There you go. Now he's a lot scarier, right? Up here and save our game. Okay, so we have other items as well, but so far, none of them use functions, right? In the end of our last stream, we were just getting the idea of defining functions. So we have this one function here for using a spear, and it's a little bit sloppy. It takes a lot of arguments, and I think today we're going to probably try and address that issue, so we can make things a little bit more straightforward. But yeah, it takes a lot of arguments. It returns the monster's new health. So you feed it all this data, right, including the monster's current health, and then the monster's health gets changed inside the function. And because things that happen in the function stay in the function, right? They don't ever leave the function unless you return them out. So this return statement here means get this data out of the function, spit it out at the end. So we change the monster's health, we print off some data, and we return the new monster's health. That's why down here, if we use the spear, we can say the monster's HP equals the result of this function. Right? Just like how we say, the used item variable equals the returned value of input, right? So this input function says, which do you want to use? Which item do you want to use, right? And then it returns whatever the user types in. So because it's returning it out, we can save it to this variable. So used item equals the return value of this function. Like if we use print right here, you can see print, right? This is a function, but it doesn't really return a value. All it does is print some data onto the screen. Right. So as you can see, it doesn't really have, we don't need to say like, printed value equals this function, right? You don't really have to do that because it doesn't return any data. However, if your function does return data, you can actually save that data to a variable name by using this syntax here. The assignment operator with a variable name, use item equals, and then whatever the return value is of your function. Right. So we do the same thing right here. We say the monster HP is the returned value of whatever use spear is. And here we're using what's called a hanging indent in Python. So we could actually have this be written like this. All the same. Right? It'd just be a really long-ass line. Kind of sloppy looking. You have to scroll to see shit, which sucks. Right? You have to scroll down here. So what you can do in Python to make it a little bit easier to read is you can use a hanging indent, it's called. That's when you go to right when your parentheses open up right here. Then you break the line. And then you indent it by not 4 spaces, right? It defaults to 4. 1, 2, 3, 4, but by 8 spaces. 1, 2, 3, 4. There we go. Because we do that so that if we have like an if statement following it, then it doesn't get confused. I'll show you what I mean by that. Right. So by having this 8-space indent here, then you can actually put an if statement right here. If whatever equals true or whatever, it doesn't really matter. Then we can have this data here, blah, 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 blah. And as you can see, it's indented differently from the hanging indent. If it were all the same, like this, it'd make it kind of confusing of where the block begins and ends. So we talked before about when you have a code block in Python. That is to say, code that will only run under a certain circumstance. You indent it by 4 spaces. And hanging indents like this are not a code block, right? These are not a code block. It's just a visual tool to break up your long lines of code. So to make it more clear that it's not a code block, you indent it a little bit more deeply. That way when you're scrolling through quickly, through somebody else's code or your own, it becomes a little bit more clear what the fuck's going on. What's up, Hog? Welcome aboard, man. Not sure we've met. Yeti Man says, what if you did 4? Would it work? 4 of what, Yeti Man? 4 of what? Oh, you mean 4 indents. Yeah, it would work fine. Yeah, it would work fine. Yeah. This would work fine as well. It's just a little bit harder to read is all. Yeah, so in Python, the reason why Yetiman asked that is because unlike other programming languages such as like C++ or Java or JavaScript or any other language you might learn out there, Python is kind of unique because although in other languages indenting is good practice, in Python it's significant. Your code will actually not run if it is not indented correctly. And some people don't like that about it, which drives me crazy. That's the main appeal of Python for me. One of the main appeals is that it enforces elegant, code layout, right? It enforces it. And it's for that reason that you can actually not worry about other languages having all these curly brackets. So other languages, you guys, not really, kind of going off topic here, but other languages use a lot of these curly brackets, right? Like this. Thank you for the follow, Yetiman. Thank you for the sub, KG. He says, get the torch. Definitely get that torch, dude. We'll get that torch by the end of today, I guarantee it. Right now we have spears, toilet paper, thumb drives, and potions. But we'll have a torch by the end of the stream for you, KG, I promise. What does PEP stand for hanging indent? It's 8, Yetiman. It's 8. You indent by 4 extra. But it's not enforced in the actual, in Python. So basically, in other languages, if you have like an if statement, they will have these curly brackets for everything, right? And that's how you know that a block starts and ends, like that. So here we have a block that starts and ends in another language, and it uses curly brackets. And that's a lot of clutter in your code. Furthermore, in other languages, they'll end the lines, every single line, with a semicolon. So you'll have something like this, right? It'll say else, and you'll have an open bracket, and then you'll end the else block with the curly bracket. And then at the end of every single line, you'll have a semicolon. That's because in the actual, in other languages, the new lines, like the line breaks and the spacing, is not significant. So you need to tell the compiler, your interpreter or whatever, you need to tell it when your commands are ending. And you tell that by putting a semicolon there. That says at the end of a command. Right? Otherwise, we can have it all be on one line if we want to, right? In Python, this wouldn't work. Because in Python, every command has to have its own line. Whereas in other languages, it can be all on one line as long as you have these semicolons in between. That really is what signifies the end of a command. And in other languages, the line breaks and the spaces are totally for show. And furthermore, for these code blocks, you have these curly brackets. Again, you can have it all be on one line if you wanted, right? That tells languages like C++ and JavaScript and Java that you're starting and ending a code block. But in Python, because the line breaks and the spacing is significant, it actually has meaning, then you can skip all that shit. You don't need to have semicolons everywhere or curly brackets everywhere. And again, in other languages anyway, it's good practice to indent your code, to break lines. It's always been good practice. So why not make it a part of the language? That's something that Python does that I think is kind of cool. And that's why Yetiman asks, if you respace the hanging indent with only 4 spaces, would it work? Because in Python, sometimes if you space things wrong, shit won't work. But yeah, indents are, the hanging indents, that's only a recommendation by Python. It's not enforced by the language itself. When Yetiman asked about PEP, he's talking about PEP 8, which is a Python style guide put forward by the creators of Python. Right? They have this list of things they consider to be good stylistic choices. And it's this big document called PEP 8. And in there, they talk about hanging indents and how you should do them at 8 spaces, not 4. Okay, I'm sorry, guys. I got a little bit sidetracked there, talking about the hanging indent. But yeah, we're going to be using that more tonight than previously. Because I kind of avoid using the hanging indent in the earlier streams in the series, because it can be kind of confusing for beginners. What you have to know is that you could have it all on one line. And it's the same thing as having it all on one line. But you can also choose to break the line and use a hanging indent so that it's a little bit easier to read. You don't have to scroll so far to the right. Okay, so in our game right now, what basically happens is we ask the player for, I'm going to find my shit here, for their name, for the monster's name, and then we have like a little battle that plays out, right? And in that battle, the monster can only do one thing, which is breathe fire, and it does damage equal to its attack power, to our HP. And our character can do 3 different things. He can attack, which will attack the monster directly, and lower its HP by our main character's attack power. We can defend, which will have our damage we take on the next turn. And we can choose to use an item. If we do that, we have a whole separate little subroutine here, right? Where we print off the items the player has in their inventory. And then they can choose which one they want to use. And whatever they choose has a different effect in the code. Right down here. If they choose item, Then we ask, which one do you want to use? If it was spear, then run this code. If it was toilet paper, then run this code. If it was potion, then run this code, right? So basically we're making a tree. It's a tree of, possibilities that the player can end up with depending on what they choose to use. So before we go any deeper, let's look at our notes from last time. Let's end this fight that we're in right now, right? Let's go here to our shell. So I want to use the roll of TP as my next turn. Roll of toilet paper. So it says here goes nothing 9, hurled a roll of toilet paper at Big Bad Faust. It wasn't very effective. It doesn't do any damage, just there for show. It's kind of cute. Big Bad Faust then again attacks, here goes, and does more damage, equal to his attack art right now. It's only 3. Let's now use the potion. We're going to use an item. We're going to use the potion. Okay, so we gain some health. It's kind of cool. Got attacks, no big deal. We actually gain some health back. Let's attack now and just finish the job, right? Just boom, fuck him up. There we go. So it ended up with Big Bad Faust has -4 HP. Here goes is victorious. Game over. So what happened there? Well, we have this, all of our battle code is basically divided up into 2 turns, right? The player turn, which is all this code here, very complex, because the player can choose what he wants to do, right? All this code here is all the player's turn. And then if the monster is still alive by the end of the player's turn, then he gets a turn, which is very simple. All he can do is do a basic attack. So it's very, very short code. But then as you can see here, the indenting stops up to this point, right up to here. We should say line 102, as you can see down here in the bottom. It says line 102. Up to line 102, all these lines have been indented by at least 4 spaces. So that implies it's all in a code block, right? Unless you're talking about a hanging indent, the only time that you would indent code is if that code's inside of a code block, which means that it runs circumstantially. It doesn't just run straight down top to bottom. So what's the code block this is all in? Let's scroll up. Okay, right here is where we see the indenting stop, right? It's a while loop. Okay, that's kind of cool. So all this code here, the player's turn and the monster's turn, are inside this while loop. And it says while the monster still has health, right? His health is greater than 0, and these both have to be true, and the protagonist's HP is greater than 0, so that he's alive as well. Then keep on looping over these 2 turns. That's kind of how JRPGs play out, right? As long as one side, as long as both sides are still alive, then we go back and forth, back and forth, back and forth. So we start off with the player's turn, then the monster's turn, then we go back to the top, because it's a while loop, go back to the top of the code block, and we reevaluate this. Is the monster still alive? Is the player still alive? If so, then do it all again. Right, do it all again. Kind of cool. In fact, we actually simplify this, right? It strikes me that... No, we actually can't simplify. I take it back. I take it back. Anyway, so... the reason why we eventually get this game over screen is because at the point that Faust's health dipped below 0, it became -4, right? It became -4 right here on the player's turn. So right here, right in the player's turn, his health dipped below 0. So for one thing, the monster did not get a turn. Right? The monster only gets his turn if he has some health remaining after the player's turn. So we skip all this code here. This if code block doesn't get executed. We jump back to the top of the while loop. And it says, hey, listen, is the monster still alive? Well, no, he's not. That's false. And is the player still alive? Well, that's true. But because of this and statement here, this while loop will only run if both of these are true. This one's false now. That means this all gets skipped. We drop down to the bottom. Right here. It says, hey, if the player still has health, then print, hey, he's victorious. Right, here goes his victorious. Otherwise, we know that the player is dead and the monster is alive. Right, because one of them has to be alive. So we say otherwise that the player is dead and we're down here, means the fight's over. Then print off that the monster has slain the player. Then print off game over. Hey, what's up, Yig? Yo, let's go, here goes. Get that CEO, dude. So when's that going to be, here goes? CEO. And... a very powerful tool, this and statement. So now we've ran our game. We've kind of reviewed how it works. Let's go look at our notes from last week and kind of catch up where we were. So it says that today we learned about function definitions, right? In the past, we've been using Python's built-in functions like print and input. A function is used by giving its name followed by parentheses. Let's go look at our function definition up here. Right? Define use spear. So def use spear, making a new function here. So can I even... maybe I can actually slide this over here, huh? We actually have both of these kind of open side by side. A little bit. Let's see here. Def is followed by a space and then the name that you want to call the function by, right? Use spear there. The name is followed by parentheses, and within those parentheses, you can supply a comma-separated list of names that you want to use for arguments that are supplied to that function, which it can then make use of. So, functions are really cool for a lot of reasons, but one of those reasons is that they are discrete, right? As your code becomes more and more complex, it becomes important to have some control over what is happening when and where, right? You don't want to have things happening willy-nilly. If they do, it becomes very hard to find a bug. So what's cool about functions is that they really can't, or let's say they shouldn't be able to influence the outside world, right? Things that happen in the function stay in the function. And one way to control that is to feed it arguments. So when you give a function some data to use, you're saying, hey, this is the data you have access to, and you have access to no other data, right? This is just worry about your own shit. Like, mind your own business. Here's your shit, deal with it. And of that shit, we're giving our function here, we're giving them the protagonist's name, such as here goes nothing 9, his HP, his attack power, the monster's name, and the monster's health. That's all that it needs to do its job correctly. And we're saying that's all the data you get, dude. You can't mess with anything else. So unlike the rest of our code here, which can use any data we've defined, right? All this code can use any data we've defined already. This function can only use this stuff, the arguments they're called. So we can give them names here, like what we want to call each argument. And then when we call that function, we can give it a comma-separated list of information, of data, and then the function uses that data as though it had this name for each spot, basically, right? So when we say here, monster HP minus the protagonist's attack power, we're saying use the data that was the last argument. Use the data that was the third argument. Right? So basically naming each of these slots that we can use those names inside the function to represent that data that we got. That's kind of cool. Now we're teaching you, I guess, that day. Fridays, we do Intro to Python. This is our episode 3 of season 3. So basically, every season of Intro to Python, we do a different project. First time it was a Pokemon game. Second time it was a text-based adventure like Zork. And this time it's more like a classic JRPG, kind of like, think of it like Dragon Quest or Final Fantasy, something like that. I find that RPGs are really good to teach programming because they are loaded with imagery, but also very mathematical. Right? It's kind of easy to understand how data flows through one of these kind of games compared to other kinds of games. And then, like I said before about functions having discrete power, basically. They're kind of separate from the rest of your code. Again, if you change data inside a function, because it doesn't really have access to the outside world, it can't really fuck with the rest of your code. So what you can do, though, is you can return data out. So you can put data in using arguments and get data out using the return method, the return statement. That way you can get some data out of there and use it in the rest of your code, which is kind of cool. Let's see here. So it says here, like any code block in Python, the function definition line ends with a colon, and the meat of its function is indented. Right? So we're talking about like if blocks, and while blocks, and for blocks, and else blocks, and elif blocks. Right? We learned that a code block in Python is some indented, code, and the first line is not indented, and it ends in a colon. Here's where you define the code block, such as, here's the definition of the while code block, right? This is where we're defining our block. Then after the line that has the colon on the end, we have the code block itself, which is indented a little bit. Same here. Here's our unindented if block, right? It's indented to the same level as its neighbors, basically. It is indented by 4 spaces, but it's not indented compared to its neighbors. And we define the if statement, the if block right here, right? If this is true, there's a colon, and then deeper indenting, right? Because we have a new code block. It's a nested code block, a code block in a code block. Thank you for the follow of somebody. Let me see who that was. I'm sorry, I've been so distracted. I actually can't see who it was right now. I'm sorry, guys. I'll fix that in a second. But thank you for the follow, whoever you are. If you want to get in the chat, come say hi. I definitely recommend it. Dig says, somehow I like text-based games. They're great, man. They're great. They can have all the gameplay of any other kind of game. They lack the graphical aspect, but you can use your imagination. It's not that bad. Yeah, where did you end up in Kingdom Hearts 2 last night? He ended with, I was watching when he ended the stream. But that game it was, he had just finished The Lion King. What's up, Turk? They finally let us use Python at work. I want to try it on Monday. Let's go, dude. Python's so sick. So the reason why I endorse Python is not only because it's got a beautiful syntax, where you can skip all the stupid curly brackets and semicolons because the white space is significant, right? The line breaks and the spacing is all important, so it makes it kind of simpler to read. But furthermore, it's very powerful. It can do anything that any other language can do, and it can do it without having to be compiled. So you guys that are total newbies, don't worry about what that means. Just know that it means it's easier to run your code. In other languages like C++ and Java, you have to go through a whole rigmarole after you wrote your code before you can run it. Whereas in Python, you just save the file and run it. It's pretty easy. Makes your life a lot easier. By the way, Vencabot says Turk Razor. Is Street Fighter 4 Fight Stick Round 2 worth anything? Nope. Nope. Yeah, Turk, fight sticks are never worth anything. Very rarely, I should say. Because every new console generation that comes out, you have to get a new fight stick to use on that other console. Yeah, there are some exceptions where a fight stick is really, really rare and very valuable, like some really old school joysticks from back in the 32-bit era for Sega Saturn and things like that, where they kind of have some collector's value. But the mass-produced fight sticks after Street Fighter 4 came out lost all their value. Okay. So we're saying here that just like any other code block, right? Just like an if statement or a while block or an elif block, functions only run conditionally. Right? They only run conditionally. Anytime you see code that's indented like this, that means that there has to be some condition met for it to run. All this code here, indented to the far left, there's no indenting, right? It's just all on the left margin. That code will always run. It just runs straight down like that, right? It just runs like that, straight down. But any code that's indented means that it has to meet a condition to run. Like this while statement, right? The while block has to meet this condition to run. The if block has to meet this condition to run. The elif block will only run if the if did not run. And finally, functions will only run if they're called. Right? If they're actually called. So right down here in a use spear, right here, we call the function by calling it by name and supplying its arguments. Right? We're calling this function here. But when it's being defined up here, this will not run. Even though it's actually above this stuff, right? Even though it's actually above our initialization code, it doesn't run because it's inside this code block. Right? We defined it up here basically. This part runs, the definition part of it runs, but the actual code inside of it does not run. So it's kind of cool. Yik says, oh man, goodness, I don't love Java or CSS. Yeah, JavaScript's kind of a whack language, but it's also not compiled. It's kind of cool. And CSS I kind of like, personally. That's called the constructor. Sorry, I just got to this stream now. Welcome aboard, Turk. Yeah, we haven't been streaming for that long yet. About half an hour. We're reviewing before we do some new stuff. I think that more or less concludes our review, though, right? We've kind of gone over real quick what we've done in the past. Let's see here. Yeah, I gotcha. So, this is episode 3. That means that we've started on the first day. We began with total beginner stuff, like you have never once programmed anything in your life. Right? That'll be available on YouTube at some point in the near future. Then we did episode 2, which kind of added some concepts. We added in elif blocks, I believe. We talked a little bit more about functions, and we added lists to our vocabulary of different types. We can talk about that real quick, guys. We know right now about essentially, I think, 4 types of data. We talked before about how every program is data and operations, right? So you have to have your operations which do stuff. That's where things actually happen. But for it to actually happen, it has to know something. It has to kind of change something or read something or take some kind of input, basically. And that's your data. So we have operations, such as our functions, including input and print and, all these cool statements, the assignments. That's all operations. But you also have the data itself. And the data itself might be a variable, like a protagonist HP, or it might be a literal, which is actually some piece of data. Right? The variable, its value can change over time, and that's kind of cool. But the literal is just the hard data. And we've learned about all kinds of cool literals. We know about numbers, like integers, which are whole numbers. We know about floats, which can have a floating point, like a fractional number. Right? So those are 2 kinds of numbers, basically. We know about strings, which represent textual data. Right? So this, if it's surrounded by quotation marks like this, that makes it a string. So this is actually some kind of text, right? We have a list here. We know about Boolean data. Booleans are true or false. Right? So they're not really numbers, they're not really text. They represent the abstract idea of true and false. So for instance, when you evaluate a while statement, you say monster HP greater than 0, this results in a Boolean that'll either be true or false. That's exactly how while works. It checks its Booleans. Even the AND statement returns a Boolean, right? So AND is an operator that says, true and true equals true. False and true equals false. True and false equals false. So AND is an operator, kind of like plus or minus in numbers, right? Numbers use like multiplication, that kind of thing. Whereas Booleans use things like AND, which are logical. So you'd say, if you have two Booleans and you AND them together, you get another Boolean as a result. Again, like true and true is true, right? Because they both have to be true. False and true becomes false because they both have to be true if it's AND. What's a 2x2 matrix? Should be Python. Here's a Python. Oh, I'm sorry, did I misspell something? Does it not say Python? Med says, I just finished a C and moved to C#. Which lang is this? Yeah, it's Python here. Yeah, we're using Python. I never used C#. How do you like it, dude? What's up, Wade? Welcome aboard, man. Is this file on the GitHub? No, I'm afraid not, Starkey. I haven't updated that in a minute. Yeah, I've been kind of busy lately. I think we haven't updated the GitHub since around the beginning of Season 2. I'm going to do that hopefully very shortly here. I hope to find some time and get that all caught up. But yeah, on our GitHub page, you can go read the entire code for the first season of Intro to Python. That would be our Pokemon game. Okay, so, yeah, we talked about, Booleans, integers, floats, right, and strings. And in our most recent stream, we introduced the idea of a list, which is a really, really cool data type. Right, really cool data type, where you have these square brackets. I'm gonna actually do a hang indent here. Now we know what that is. I've kind of been kind of shying away from doing this because I didn't want to overwhelm the total newbies with these hanging indents, but I like them a lot. So we can have this all on one line now. So we have these lists, right? And they're enclosed by square brackets, and they're a comma-separated list of data, right? So we have a bunch of strings here. A string, then a comma. Then a string, then a comma, then a string, then a comma. We have 1, 2, 3, 4 entries in our list. And what's really cool about lists, man, is that they have all kinds of cool features. So we can do things like get a Boolean out of the list by using the in operator right here. Right? This little statement here, spear in player inventory. So, this string in this list, it's a Boolean equation. And it returns true if this item is in the list. It returns a true Boolean. If it's not true, it returns false. Right, that's kind of fucking sick. So we can actually make our code more intelligent now by having it test things like, okay, well, only run this code if this item is in this list. Furthermore, you can add things to the list using the append method and remove them using the remove method. Right? So if spear is in the player inventory, then use the spear, and then remove the spear from the inventory, right? We talked last time about what a method is. It's kind of we're going to explore that more today. But basically, think of it like a function, kind of like print, or input, or use spear that we defined ourselves, right? Think for the follow somebody. I'm sorry, guys. I wish I could read. I need to go fix my my UI so I can read it while I'm streaming. But think for the follow somebody. I appreciate that. But think of it like any other function, except that when you have this dot here, this is Python's way, and in fact most languages' way, of expressing ownership. So in English, we use an apostrophe S for ownership, right? Like the player inventory's remove function, right? Apostrophe S in English. But in programming, you almost always use a period instead, like this. That means use the player inventory's remove function. So if a function is owned by another object, it's called a method. It's the only difference between a function and a method, is that a method is an owned function. And what's cool about that is that anytime you have a method, it will actually have access to its owner without needing it as an argument. We talked before about how arguments work, right? A function can only use data, ideally, that's supplied as an argument to it. It doesn't really have access to the outside world. So when you have a method, you can actually save yourself an argument because it actually has access to its owner. So even though here we're saying, remove spear, you might ask, well, if it's a function, how does it know what list to remove it from? Well, because it's actually not a function, it's a method, and its owner is the list it's going to remove something from. So it saves you an argument slot, basically. And it makes your code more readable, because when you have objects that own other things, it helps you categorize things in your mind, right? That way this list has these attributes and these methods, and we can learn about that list using these things that it owns. So Turk says, a dumb question, but since Python is a high-level language, why do you have to define floats and ints? In R, everything is forced as a float unless you specifically force it into an int with the L operator. You don't have to force anything in Python Turk. It uses duck typing. So in other languages, guys, when you define a data type, or define like a data, a value, like a protagonist HP, you have to define what it's going to be. You might have to say, this is going to be an integer, right? That's how you do it in other languages. It's going to be an integer here, and that way it's going to always be an integer, and that's fine. But in Python, they don't do that as strictly. Instead, we have what's called a duck typing, which is called that because it follows the philosophy of if it smells like a duck and looks like a duck and quacks like a duck, it's probably a duck. Right? That's why it's called duck typing. So that means that as long as your function can do its job based on the data it's given, it doesn't really matter exactly what kind of data it is. In Python, things default to being integers just because it's a little more memory safe. It's a little bit less intensive than a float. But as soon as Python needs a float, it will give you a float. I'll demonstrate that right now. All right, let's go to our command line here real quick. Right. So if I were to run the py command in Windows, it brings up an interactive Python interpreter, which means that we can actually type in our programs line by line and see how they work. I've kind of shied away from doing this. It's not, in my opinion anyway, it's not really the best way to learn Python. Some people disagree. But basically, we've been learning it as you write a text file and then run that text file. Right? But Python comes with this interactive interpreter where it'll run each of your codes line by line. And we're going to do that right now to demonstrate how integers work. We're going to say, first integer equals 1. Right? And second integer equals 2. Now we can add them together, right? Let's say first int plus second int, and it gives us an integer, 3. But if we were to divide first int by second int, we're supplying 2 integers, right? But we can't get an integer back because it's going to equal 1/2. It's going to equal 0.5, right? So what's going to happen? It's going to crash. Other languages would freak out because we're using 2 integers with an operator that might expect an integer in return. Well, that's fine. We just get a float back. It's no big deal in Python. It just does it automatically for us. So I think hopefully that answers your question, Turk Raiser. But yeah, there's definitely, ints and floats are used more or less interchangeably 99.99999% of the time in Python. But yeah, they go back and forth very easily between ints and floats. It's no big deal. They're pretty much interchangeable. I just use integers a lot because I think they're easier for beginners to understand. Right? It's kind of easy to understand 25 rather than 25.0. That's the only difference, right, in Python. And again, Python, if it can use an integer, it probably will because it's more memory safe. But if it has to use a float, it definitely will. It's no big deal. So Wade, sorry I've been around lately. You've been doing some I'm sorry, Wade. Yeah, welcome back, man. I feel like you've been around here, more or less as often as usual. It's always a pleasure having you. Everybody's got personal shit. Don't have to be ashamed of that. So Fal says, do you only have 30th on PS4? Okay, so he doesn't have it on Steam. I'm waiting for used PS4s to drop in price so I can pick up 30th on PS4. Okay, so you actually don't have a PS4 at all. You're a PC master race. What's up, Ziducky? We're doing some programming, dude. We're talking about programming basics for novices, basically. I'm trying to teach programming, essentially. Alex sold Wade his old PS4. Nice. Couldn't you also use a symbolic toolbox? I have no idea what that is, 2x2. Maybe I could. Faust says, maybe I will post in the FB group asking around. Fody told me they have like $200 at PA right now, which is unreasonable. $200? Yeah, aren't they like that full price, more or less, these days? Like the original version of the PS4? Okay, so let's close the interactive interpreter here. I don't like to use this that much. I'd rather just do it in, text. We're using idle, by the way, guys. In our first episode of Intro to Python, we used Notepad to prove to total beginners that you can program just fine in Notepad with no extra software at all. But Python comes with a program called idle, which is a little bit nicer. It's kind of like Notepad, but it has syntax highlighting. So it's easy to scroll through and see at a glance what's happening. You can see things like statements, like while, are highlighted in a different color. And functions have different color, highlighting. It's kind of nice. Strings appear, they kind of jump out at you, so you know what's a string and what's a number. It's kind of nice. So today, guys, what should we look at? Let's go to our notes here. Right. And we're going to go here to the very bottom. We're going to say here, hey, it's, the 1st of February, and it's finally, I'm actually going to emphasize that, finally, Intro to Python, Season 3, Episode 3. We've been putting this off for a while. I've had a lot of shit going on in my life where we haven't been able to do this every single week the way I would like to. It's finally Episode 3. What are we going to look at today? Well, today, we're going to add a new data type to our repertoire. Not sure how to spell repertoire. Things like that. We were just talking about how we have a pretty small list of data types in our toolbox. They are as follows. Integers are whole numbers. Floats are fractional numbers. Bools, or Booleans, are true or false values and are used for logic, especially in the conditions for blocks like if. We learned about strings, which are textual data that are often shown to a user at some point, because the computer doesn't really need text. It doesn't need to know English or Japanese or French or whatever, right? It doesn't usually need text itself. So if you're storing a string, it's probably going to be shown to somebody at some point, like somebody's name or a date or something to print on the screen. Anything that's going to be shown to a user, probably going to be a string. This is textual stuff. And we learned about lists. Sweet lists. They're a sequence of data that have all kinds of cool purposes. You can get Booleans out of them by testing to see if a certain piece of data is in them. You can add to a list. You can subtract from a list. Maybe most importantly, you can iterate through a list using loops such as for. And what do I mean by that exactly? I'm going to go kind of review that real quick. So basically, we have these lists, right here. It's got a bunch of data in it, separated by commas. And yeah, we can check to see if spear is in there. That's fucking sick, right, as a condition. But even more importantly, we can go through using this for loop right here. So if the player chose the item option for their turn, we print off the words you have, and then for every inventory item in this list, player inventory, then we print off 4 blank spaces followed by the item's name. All right, so what does this mean exactly? When you have a for loop, we know about a while loop, right? We have 2 kinds of loops now. The while loop will keep on going from top to bottom as long as its conditions return true Boolean, right? So this will return a true, hopefully. This will return a true, hopefully. And then using this AND statement, which is a comparison operator for Booleans, or it's like an operator basically, we can get one big Boolean out of it. If this is true and that's true, then we get true here. If the condition is true for the while statement, it runs indefinitely, right? That's kind of how loops work. But the other kind of loop we have is this for loop. And a for loop will go through its code block. There's only a 1-line code block right here. It's still a code block though. It'll go through this code block once for every item in the list. And it will call that item, it'll call that list item, whatever you chose right here. So we can call this, for whatever, right? For whatever in player inventory. Then print off 4 blank spaces and then whatever, right? So for every item in the list, do this thing to it. So it'll print off spear. Then it'll do the same thing for the next item. It'll say, it'll say toilet paper. It'll say potion. It'll say thumb drive. It does it for every item in the list. And that's really powerful, guys. The for loops are what makes lists so sick. It's really, really powerful. If you guys are total novices, you might not really understand how it's going to be significant to you later on. But trust me, as you learn more about programming, you're going to find out just how useful for loops are. They're really sick. Hey, thank you, Kenny. Dude, I was so stressed out yesterday, man. It's a pleasure to be back. It's a huge pleasure to be back. Hopefully you had a decent day so far. Hey, what's up, Dix? So heard you were having problems with your pipes. Don't worry, that's normal with old age. Wow, Dix. Yeah, guys, yesterday I had a really shitty day. I had a really shitty day yesterday, but I'm finally back, and I couldn't be happier. Yeah, I'm pretty fast at typing, Turk Razor. Mario teaches typing. Stream would be sick. Dude, I'd fucking body that game. What's up, DJ Isco? How about that do while? Yeah, do while, that would be, I think you're talking about basic, right? Isn't that a basic thing? What's up, Rico? Python doesn't have a do while loop, just while loops, yeah. What is this madness? How do you even code? You type stuff that works. Typing on the dead stream when? I actually talked about that before. That'd be kind of fun too. Okay, so let's go back to our notes here. These are our 4 kinds of data we have right now. Integers, floats, bools or booleans, strings, and lists. But, today we're going to learn about another super powerful data type, right? And when I say powerful, I mean totally sick, right? Real ultimatepower.net. I'm talking about, a data type that, as you mature as programmers, you're going to find all kinds of cool uses for. And that's a dictionary. Right. Dictionaries are known within Python as dicts, right, like a dict, basically. And they're also called maps. The reason they're known as maps is because you map one piece of data to another piece of data, and they become associated. I'm going to go demonstrate that real quick. So I'm trying to think of a good way to do this right off the bat. I think the best way would be to do a very quick example that's not related to our RPG necessarily. Let's make a new file here. I'm going to save this new file as finally learning about dicts. Right, not about our friend Dick Sucker in the chat, but about dicts, like dictionaries. It's a dict. They're known as me, exactly, dicts. They're known as dicts. Do while is also in Java, I didn't know that, so it's probably in other languages as well. Do while, huh? I don't remember that. I haven't used Java in forever, though. I used to use Java as my main language back in the day. Dude, so much water, DJ. So much water. Yesterday was just crazy. I couldn't shower. I couldn't do anything. So, Rico, you ever do any programming before? Sounds like you've done some. What if I want to know more about dicts? Just ask him. He's very forthcoming. So we're gonna learn about dictionaries, right? So let's make a string, right? We're gonna say my string equals, Rico is here. 'Cause I'm so happy Rico's here. They're gonna say, my integer is, how happy I am that Rico is here. That's gonna be over 9,000. Right? That's how happy I am Rico is here. Then we can say, we'll make a second string, and we'll say, Dick Sucker is here. We'll be how happy I am that Dick Sucker is here, and we'll put that somewhere in the ballpark of, 2,520. Right? Something like that. So now we're gonna have this dictionary. Right? We'll say, our dict, just naming these random names for these variables. And we're going to use curly brackets. So when you define a list, you use square brackets, right? Kind of like our inventory over here. We define this list. Where is it? Right here. And we enclosed it in square brackets. That's how you define a list, right? But for dictionaries, you use curly brackets to define your list. And we're going to map one piece of data to another piece of data. We're going to say here, you know, we're going to call this, we'll make it more clear. We'll call this Rico string, and then a Rico int, right? And here we're going to have a Dict string and Dict's int. So it's more clear what they are. Now we're going to map the Rico string to the Rico int. Right? We use the syntax here. We use the what's called the key, or the primary piece of data we're going to be using to access the other thing. Right? This is the key, followed by the colon and a space, and then the value for that key. Right? So Rico string is the key, and then the value is how happy I am to see him, 9001. Then we're going to have our Dict string as our second key. You can see the comma separation there. We have a comma. Dict string is the key, colon, space, and then Dict's int. So we have a dictionary now that has two values, right? It has two entries, basically. And every entry is a pair. It's a key, and then an associated piece of data, right? Key, and then the value. Here's how you use Dicts, though. They're really cool. We're going to print off something like this, right? Well, let's make a function. We'll say def, you know, how happy am I? And we're going to have to supply, you know, a string. You know, we're going to say, you know, key string, we'll call it. Right. What we're going to do is we're going to print off the string. Right. We're going to say, you know, my happiness to see them is, right. I'm going to do it like that. No, I don't want to introduce that yet. Let's do it like this then. Plus the string version goes to integer. We're going to make it into a string so we can add it together. The string version of, we'll call this happiness string, right? Let's print that off. We're going to make a happiness string. Happiness, we'll say int to string. Right? That's going to be, you know, a string for our Dict. Oh, we need to have the dictionary too, don't we? Let's get the Dicts here. The string from our Dict. We want to get the key string. Kind of complicated looking, right? I'll explain in a second here. Print off int to string, basically. Okay. Cool beans. Now let's run this code. Hopefully it works. So we're going to say, how happy am I that Rico is here? Right, let's see if this works correctly. Oops, I fucked it up. Oh yeah, I need to have the dictionary as well. Okay, run that again. I'll explain why this works, or why it doesn't. Oh, didn't work. Yeah, I need to have int there. Okay, run it again. All these typos. Now we're talking. So it says here, Rico is here. My happiness is to see them is 9001. Right, I think Kenny's always catches my typos. He's still on top of things. Unlike me. Right, so it prints off, you know, the string that I used, Rico is here, and then its associated value, 9001. I'm going to try this with Dicts now. We're going to use the same function, how happy am I, but we're going to say Dict sucker is here, and give it our Dict. Right, and see what happens with this. Run the method, run the module. And so Dict sucker is also here. My happiness to see them is 2520. Okay, so why is this dictionary so fucking cool? Let's talk about that real quick. So we made two strings. Rico is here and Dict sucker is here. And we used this map, or this dictionary, to associate one string with one value and the other string with another value. So inside this dictionary, these things are associated with each other. They're essentially a pair. They go together. So if we were to take one of these strings and the dictionary, right, in question that has it, we can print off, sure, we can print off the key string, but we can also get the value out of the dictionary that's attached to that key. Right, let's actually just simplify this, right? But here's a example I always tend to use, right? We're gonna make a color Dict. I like to do this a lot. We're gonna say here, you know, apple, red. Banana. If you guys have been watching Intro to Python, you've seen this before 100 times already. Banana. Yellow. You know, pineapple. Oh, we can't use pineapple. It's already yellow, right? What's another good color for a fruit? Well, what are good colors that exist? Let's use those two. I'm not good with colors. So this dictionary has got 2 entries in it, right? Now we can print off. What color is an orange? I don't know. I wish I knew. Print off color dict apple. Okay. Watch what happens here. Run it. It prints off red. Okay. So we have this dictionary. It has 2 keys and a value for each key. Then we can get that value out by using the name of the dictionary, color dict, then square brackets for some reason. You'd think it'd be curly brackets, but they're square anyway. They're square brackets. And then between those square brackets, you put in the key. Thank you, DJ Isco. Pear is green. You guys got my back. You guys are all slacking. All right, so I go here and add in this pear. Right, instead of the apple. It's going to print off green. Right, prints off green right there. Grape, perp. Let's do that. Grape, perp. And we're going to use a hanging indent here, guys, to make it all go onto one line more in a more beautiful way. There you go. Hanging indent. That way it doesn't have to scroll to the right. So let's go try the grape. Right. Just to print off perp, you would think. Run. Module. Perp. So what's cool about dictionaries is that you can kind of pair data together that makes sense. So you can actually get the color out of this dictionary by supplying the fruit you want, and it gives you back the color because the fruit name is associated with the color. Right? And what's interesting about this in Python is that you can associate all kinds of crazy shit. Not just a string and a string, but a string can be associated with a integer. Or you could even do crazy shit like this. Like, we'll have like, how about, crowd dict, right? We're going to associate an integer, such as 1, with a string, lonely. Then we can have something like, 2 can be company. 3 can be crowd. 10 can be, anxiety. Right? 20 can be get me out of here. Right. Let's do another hanging indent here, guys. Because see, it kind of sucks to scroll, right? Let's just drop this down and indent it by 8 spaces. Right? Then go here, where it's scrolling off again. Do the same thing. Boom. Easy peasy. Are you coding in Notepad? We coded in Notepad on our first day, but we're using Idle here. Idle is a editor that comes with Python. It's kind of cool. It's very basic for an IDE or an integrated development environment. It's really more like Notepad than something really complex, but it highlights syntax, and you can actually just run your code from here. That's what I like about it. It's got some other cool features as well. So we have this crowd dict, right? And we can associate something like an integer with a string, such as, we can say here crowd dict. I want to find out, what 3 is, essentially. And let's run this. 3 is a crowd. Okay, how about, 20? Right, run that. It says, get me out of here. So basically, you can associate any kind of data with any other kind of data. And a question I get a lot on this Intro to Python is, what happens if you have 2 things that have the same key? Like, we have the same key here. We have a 1 that's lonely and a 1 that is, Let's try and see what happens with this. I think it might be a syntax error. We'll see. It might actually run, but it's going to give us a kind of a weird result. Yeah, see, so the result is right? Because they're overwritten. So every key has to be unique, right? It makes sense because you have to call it by its name. So you can't have 2 things by one name because, the previous one will get overridden, right? So we lost lonely because we redefined what one was associated with. That's why people ask, they say, well, you can get, you can type in, crowd, 3 comes out as crowd, right? If I run this, I should say crowd. Yeah, crowd. But can I type in crowd somehow and get 3? Because they're associated, right? They're associated. So can I type in crowd and get 3 somehow? The answer is no. Not really. You can if you hack. It's not that hard to hack. But no, because the key is unique, but the value can be anything. So we can actually have these, let's say I want to have, 10 be a crowd, and 20 be a crowd. I can do that. I can definitely do that. So that's why we have a problem then trying to use the value to get the key, because the value is not unique. So you can't say, I want the key for this value, because this value might have, might be on 10 different keys. Right? So you can't really do that. Again, you can hack it pretty easily. I'm not going to go too much in depth about that, though. It can be done. But if you're using the right mind state, that's not really what you want to use a dictionary for. You're really using it to punch in a key and get a value out. That's what's really cool about dictionaries. So, how are we going to use dictionaries in our code? Well, here's what I recommend. Here's my idea for using dictionaries today. Oops, let me go get my my simple RPG here. We have this use spear function right here, right? Where we have a huge list of arguments. It comes with all kinds of crazy arguments here. And it can take up a lot of space, kind of sloppy looking. In fact, if you go down here where we use the function we're defining, if we go down here to where we use the function, use spear, look at this fucking line of code we have. This is really only one line. It's broken over 3 lines to make it easier to read, but it is one line of code. So we have an assignment here, monster HP, equals, and then we supply a whole bunch of arguments, 5 arguments, to this function we defined, use spear. And it kind of sucks. Kind of sucks. But what if we wanted to have a uniform method of calling functions? Let's say that we have these, we'll call this like an item use, item use function, right? And we're gonna have one of these for every kind of item use. Then it would make sense to have like a standard of what arguments they take. But here's the problem. Something like the role of TP doesn't require anything except for the protagonist name, right? Because it doesn't really do damage, doesn't really do anything interesting. All it needs is the name to print this out, print out this message. That's cool. Except that by having all of our functions take different data in, it can be sort of confusing to read and to add new functions. It might make more sense to have them all be uniform. That way we can swap them in and out very easily. So how about instead of taking all these arguments, like 5 different fucking arguments, how about we make a new kind of object? Right? I'm gonna say, how about we make an object called like game state? Right? Looks like I'm gonna do it down here actually, to demonstrate something to you guys. We're gonna get a thing called game state. Right? And it's going to be a dictionary. And we're gonna associate a string like protagonist name with the value of protagonist name. We define that up here, right? Let's do that for everything. Let's just go through and just do that. We're going to say here, also, save the protagonist HP, with the key, with the string. Very long, I love very long variable names here. So basically, if you guys are programmers, whether you're beginning or long-time programmers, deciding on your variable names is super creative and very important. Some people enjoy having shorter variable names so that they can fit more data on one line, make it a little bit easier to read in that respect. I prefer to having really long variable names so it's explicitly clear what they are. Like, it could not be more clear what they are. For that reason, I have to use less comments. You can actually comment your code to explain what it does to people. I find if you use long enough variable names, you can actually forego that because it becomes totally clear what your code is doing at all times. Hey, what's up, Gator? Is it easier to keep user stats inside of a class? Indeed, it is, Gator. We're going to be doing that next Intro to Python, episode 4. Episode 4, we're going to talk about classes. They're kind of like souped up dictionaries. So we're doing dictionaries first, They're very powerful. They're awesome. But when we start talking about classes, oh my god, it's on, dude. They're so cool, so powerful, and they can make your code way neater. Is snake case common in Python? No, DJ. In fact, it's only used for... oh, no, I'm sorry. Yeah, this is snake case, right? So basically in Python, when you define instances, like variable names or function names, you use what's called snake case, which is all lowercase, and you separate words using underscores. In other languages, like Java, you use what's called camel case a lot. Or use... camel case would be like protagonist name. Right? That's a standard in Java. Thank you for the follow. Thank you, Mutant, for showing up. He says, hey guys, 100 biddies. That goes a long way, dude. Thank you. That 100 bits helps me buy groceries and stuff. Dude, I'm so fucking happy to finally be able to drink some water. It goes so well with the food that I eat. It's so great, man. Having something to drink with your food is just, oh man, what a luxury. Gator says, do Python standards dictate that you have to use variable names like this? Yes. I usually use camel case, or does that go against PEP? It does. Yeah, so in Python, if you use camel case like this, where you have a lowercase start of your, a lowercase first word, and then subsequent words are capitalized on the first letter, that's called camel case. That's a standard in Java and in JavaScript and maybe also in C++. It's pretty common in those languages. And although they work fine in Python, you can call your variable whatever the hell you want, but in terms of standards, it's frowned upon. You want to always use snake case. And that way people know, from looking at your variable name there, what it is. They know it's a variable. They know it's some kind of data. And in Python, class names use a title case. So that title case is when you capitalize the first letter of every word, including the first one. Right. So in Python, this would be a class, protagonist name, and this would be a variable of some kind, protagonist name. That way you can tell from looking at it what it is. I missed a message here. So Starkey says, classes are awesome. What's made my Space Invaders type game? Yeah, classes are really, really great. We're going to learn about those next time, next Friday. And I guarantee you our code's going to get a lot cleaner, like a lot cleaner. What we've learned, guys, is that as we use more basic programming concepts, like the more basic stuff for beginners, it's easier to learn at first. But then as your program becomes more complex, more involved, then it starts to look really ugly and very hard to read. What's really cool about programming, guys, is that as you grow as a programmer and you learn more complicated ideas, then your code surprisingly becomes much more legible and more clear, because you can use these more advanced concepts to simplify your code. So because we're kind of beginners here and we're using only very basic concepts, our code is getting a little bit ugly. It's very long and very deeply indented. So hopefully by using dictionaries today, we can make our code a little bit more easy to read, even though if it was our first day, it'd be way too much to learn how dictionaries work. Thank you for the follow, Blue Moon. So Gator says, good to know. I've been using camel case in Python. Guess I'll make the switch. It can be hard, Gator. It can be hard. If you use like more than one language at a time, like let's say you're working at at your job and using Java for this and Python for that, it's kind of hard to break old habits for sure. But I recommend it. As a longtime Python programmer, I really prefer snake case. When I go use JavaScript, again, it's kind of hard for me to adapt to using camel case. Sometimes I might even just use snake case, and then JavaScript programmers will get mad at me when they read my code. What's up next? It's a game indeed. Yeah, we're doing our intro to Python here. It's not the same as our other game we're working on. This is just a tutorial for beginners. We're using a game as an example here. I think classes are the only place they use camel case, but I need to brush up on my PEP 8. Yeah, it's actually not the same as camel case, it's title case. In title case, even the first letter is capitalized. Are you covering classes? They always confuse me. Yes, exactly, Gator. On next Friday is going to be classes here. Starkey says, I've been really enjoying the Invent Your Own Computer game with Python book. Well written. Oh, cool. Maybe we should link it, put an Amazon link. I never heard of that game before. Good night, Kenny. You might see Rico later, he says. Depends on what happens after the show tonight. What show? Maybe Kenny's already gone. He can't tell me what show he's going to. Maybe he's performing. Kenny's actually a musician. Okay, so we're defining a new dictionary down here. Right? Let's go through, and our goal here is to add every variable that relates to our game to this game state dictionary. I'm going to show you guys why we're going to do that. So let's make the practice HP there. I'm going to skip this HP text thing for now. This is really more of a thing we added for total beginners in our first day, because we're just going to convert back and forth to string when we need to. So basically, this str function here it will convert some piece of data, or shouldn't I convert? It will take a piece of data as an argument and give you back a new piece of data that is the string version of it. Right? And the reason we use that, let me go to my example over here, our little example code. Right? The reason we do conversions like that, if I were to say here, you know, my name equals David, and my age equals 31, I can't do this. Print my name plus is plus my age plus years old. I can't say David is 31 years old. It would make sense if you could, right? That would make sense. But if I run it, watch what happens. Run module. It says you can only concatenate strings, not integers, to strings. So you can add, I could add 31 to 31, and it would be 62. And I could add David to Hernandez and get David Hernandez. But you cannot add strings and numbers together because they behave differently, right? When you add numbers together, they sum. They sum together. But if you add a string to a string, they concatenate. They get combined, basically. So you can't add a string to an integer. However, you can use this cool built-in function in Python, str. What this will do is it will give you back a string from any kind of data. So it'll turn something like 31 to 31, right? It turns it from being a number, which can have math done to it, to a string, which is text that can be printed on the screen. We talked before, right, about how, you know, 31 plus 31, that would equal 62, right? However, 31 plus 31 equals 3131, right? Because that's how strings, they don't get added, they get concatenated with that plus symbol. They get kind of squished together, whereas numbers actually get added together. So you can't print off, you know, David is 31 using the integer, but if you get the string version of it, that's fine. That's what str is for. And on our first day, I thought that was kind of advanced for our beginners, so I kind of made this special variable whose only job was to be the string version of the health. But from now on, guys, if we need the string version, we'll just use str in our code, right? We know what that means now. Str means get the string version of that thing. It's called, I always called it upper camel. Title case, it sounds right, though. Yeah, title case. Cases, I'm not performing, I'm just watching, but the headliner is Marty Friedman, the old guitarist for Megadeth. Ooh, hope you have fun, Kenny. Thank you for that link, Starkey. Anybody in the chat who was interested in learning Python, maybe check out that book. Sounds like Starkey recommends it. But you can do it with a print, my name is my age years old. Yes, you can. Indeed, you can, Pet TV, you're right. You're right. So what Pet's saying is that the print function in Python, it's a pretty complex function, more so than it would kind of lead you to believe. I've been kind of trying to avoid using the various forms of print because it's been kind of confusing how it behaves differently in different situations. In fact, I wish they would fix that. I think it's kind of not really Pythonic how it handles different things differently. But yeah, so basically, print will take a list of arguments as well and print them off as though they were strings. So here we're giving it one big argument, right? Where we're saying, you know, all this stuff is just one piece of data, essentially. But we can also supply more than one argument. Let's say, you know, my name is my age years old. So here's, we have 4 arguments, right? We have one string, my name. We have another string, which is enclosed by spaces. We have another argument, my age, which is a number. Then we have years old, which is one more string. So we have a string, an integer, and a string. And what Python will do is it'll print off all these things on one line. And if it's not a string, it will convert it to a string. So Pet's right. You can actually do this by default with prints behavior if you want to give it more than one argument. But to this point, to make things more easy for beginners to understand, I've been basically using print in the form of only using one argument, which is what you want to put on the screen. But indeed, print will print off a list of things, like a whole bunch of stuff. And everything inside of print will get turned into a string for us. He's a dude, use format. Format is great. In fact, in Python 3, you don't even got to use format, one PyCoder. Let's touch on that, kind of a more advanced topic. Let's touch on that very briefly. Right. So basically, what PyCoder is saying is that, although we did it like this, we did it like my name plus, you know, is plus the string version of my age plus years old. right? So David is 31 years old, right? What PyCoder is saying is that in Python 2, we're using Python 3 now, but in Python 2, you could use this cool function. It would be like this. Well, so let's use this one first. All right, let's run this. Yeah, so David's 31 years old, right? That works. But we can also say, we can say, here's a string, right? We're going to say, weird little brackets is weird little brackets years old. It's a pretty fucky looking string, right? It's pretty fucky looking. But you can use this format method. Every string has a format method. Format my name and my age. Let's run this, see what happens. Run it. Hey, it still works. David is 31 years old, right? So what it's doing here is when you have a string, every string has this format method that can be used on it. And what it does is it takes a couple of arguments, or any number of arguments, and it will slot those arguments into the string wherever it finds these two characters, basically, right? The curly brackets. That is cool. But you know what's even cooler, guys? Fucking Python 3 has a feature I'm very excited about. I love this feature. All right. In Python 3, you can do F strings like this. Boom, boom. My name is my age years old. Oh my god, that syntax is so godlike. It's so easy to read. It makes so much sense. Oh my god. If you run this, David is 31 years old. So this is what's it's new in Python 3. It's called an F string. It's a string you start off with the letter F. And then anything inside curly brackets inside that string is evaluated in Python to a value. So we can use things like variable names. We can even do math, I believe, inside these things. I might be wrong about that. You know, is 30 plus 1. I think we can do that, right? Let's try. Yeah, so it evaluates the code, basically. It evaluates the code inside the curly brackets and makes it into a string for you. So I'm saying one PyCoder, a string to God. So yeah, F strings are great. I'm going to probably not utilize them extensively here because for beginners here. I think it makes more sense for beginners to look at strings as things you add together. I'm not going to worry about formatting too much. We're going to stick with things like, my name plus, is plus, string version of my age plus, years old. I really want to stress to beginners that strings can be added together. That's what I want to stress. But indeed, F strings and formatting, it's probably how you want to do it. It's more clean in the long term. But for now, I think it probably makes more sense to just add things together. Zebus says, yeah, that's the proper way to do it, instead of using old concatenation. Yeah, I don't know. I think that, I wouldn't say it's technically proper. I think there is no standard put in place for programmers to say to use one or the other. But I think that F string is probably easier to read in general. But again, for a beginner, this might be easier to read rather than introducing the idea of formatting F strings and curly brackets. The idea, I think it really drives home that you can add strings together. So, yeah, because you're sending one argument to print, so that argument has to be the same type of data exactly, Kenny. This format function is so C-like. Yeah, it's kind of a drag. I don't remember if I said it before, but I registered. Yeah, you did, yeah. No, okay, wait, you unregistered? Oh, no, you did register. Okay. Before I left, I thought, yeah, you said that before. Yeah, I asked you what the date was. I'm there. Actually, you got back to me. Thank you, Artie Fuffkin, for the follow. We do programming here at least once a week on Fridays. This is Intro to Python, our Friday show, where I try and teach Python to total beginners who have never programmed before in their lives, basically. But also we're doing some more creative streams here on other days of the week where we're going to be making our own JRPG. It's a little more involved in this, though, in the future. Longhand is better than shorthand for new programmers, maybe, as it shows better logic. I guess you're right, Zebus. Good way of saying that. Hello, JavaScript, yeah. 1 plus 1 equals 11, yeah, very confusing. It's June 28th through the 30th. Okay, cool. It's out there in the middle of summer in that sweaty-ass Florida weather. All right, so we talked about... I got sidetracked. What were we talking about again? Oh, yeah, we're talking about the string function, right? It converts... I shouldn't say converts. It gives you back a copy of a data type as a string, such as an integer as a string. Likewise, we can do things like this. Watch this. Let's go back to our example here. We can use another function. Thank you for the follow, one PyCoder. We can use another function here, such as, I will say, first number, thank you Peta TV for the follow, equals, 1. And then second number equals 2. We can print off them. No, thank you for the follow, Zebus Aqua. Boy, lots of follows. Thank you guys. I appreciate that. I'm really into programming here. We do some gameplay on the channel as well. Lots of Street Fighter 3 Third Strike, some Smash Brothers. There's gonna be some Minecraft later tonight. We're gonna print off first number plus second number. You guys already know what's wrong with this, right? We talked about that in the chat already. If we run this code, we're gonna get 12, right? But 1 plus 2 is not 12. It's supposed to be 3. But because they're strings and not integers, they get added together, they get concatenated, right, into 12. 1 and then 2, not 1 plus 2. But we can use this integer function, which is very similar to the str function, right? So str turns data into a string, essentially. It gives you back a string version of that data. This gives you back an integer version of some data, including strings. So if we run the int function on our strings, we will get integers back. There, now it says 3, right? Because now it's giving us the integer version of that string. So basically, we have these cool functions in Python that can give you back a new version of your data in a different type, int or str. And I'm trying to avoid the word conversion because we still have these old values, right? First number did not get converted into an integer, right? It's still a string. It's just that we got back an integer version of it here. If I were to, I can still go down here and say, print first number plus second number, right? And we're still going to get 12. All right, watch this. Run the module. So it says 3 and then 12, right? Because we didn't convert this to an integer. We just got a new integer out of it, basically. Yeah, no, Zebus. I don't know what would be a better word. But basically, we're kind of like, we're returning an integer from an argument that is a string, right? We're getting a new integer back out. We're not converting anything. If you, my partner, and I all split a hotel room, it'd be like $183. Wink, wink. Yeah, that sounds... I know you guys are ace as fuck, but still, that's something I wouldn't be totally comfortable with. I'm not trying to be the third wheel in a couple. But I'll keep that in mind, though. Thank you for the offer here, guys. Type conversion is used a lot and very important to learn. Yes, very important to learn. In fact, it drives home the idea for beginners that data is of a type, right? Data has a type, and those types are used in different ways, right? Numbers are used differently from strings, and strings are used differently from lists, etc., right? We have these cool data types we've been learning. They each have their own function, their own abilities, which is kind of cool. Coercion, maybe? Maybe. I do love coercion in real life. Back to our game. We have, about an hour left to stream here. Back to our game. Let's look at this dictionary, right? What we're doing here is we're trying to combine all of our existing values, all of our existing data, into one big lump, which definitely has its ups and downs, right? We're going to talk about that probably next stream, about the ups and downs of combining all your data into one big lump. But for our purposes today, it's going to be of good use to us, because that'll allow us to do things like use spear, and later, item use potion, right? Hypothetically speaking, these aren't really real functions. We're just kind of making these here to kind of hold space, like space holders for now. They don't really do anything. Use toilet paper, right? Don't really do anything. But we're gonna have all these functions that take the same simple argument. Because right now with this one big function, look at all those goddamn arguments it has. It's very complex and sloppy looking. So we're going to combine them all into one big lump, and then use that lump as the argument. And again, that's definitely, don't get me wrong, guys. You guys are more experienced than some of the other users here. You might realize that has its downside. We're going to talk about that more next time. But for now, it's a great thing. We're going to combine all of our stuff into one big lump. It's fucking fabulous. Let's do it. So we have this HP. Let's do it like that. We have the protagonist attack. Okay, we're going to do that. But, you guys, again, the guys that are more experienced than some other people here might realize this is mad redundant. This is fucking redundant here, right? You can see, even if you guys are beginners, you can see that, right? Protagonist name is protagonist name. HP is HP, right? So here's what we can do to fix that, guys. Why don't we go up here instead and define the game state dictionary first. Like that. But it's empty. It's empty. But what we can do then is we can add new keys So in our other example, our color dictionary, right, we did like, apples red and bananas yellow. We define the dictionary all at once. But you can also add things to it, over time. It starts off empty, but you can add a new key like this. Game state, protagonist name, equals this value, right? Game state, protagonist HP, equals this value. So now we're adding new keys with new values to our dictionary. That we're getting all of our data into one big object. And I want to stress one more time that starting on next Friday, that's not going to always be a good idea. In fact, even right now, it's not necessarily a really great idea. But for beginners, as a way to learn dictionaries, this is the best idea. There we go. We're going to combine everything we have into one big dictionary. It's going to have everything we got to know about the game. It's the whole game state, right? It is the whole game state, this thing. And inside that game state, we have all this data that's associated by name. We talked today about how dictionaries will associate one kind of data with another kind of data, right? Here we're associating a whole bunch of strings with, what that data represents in the game. These strings include, I'm going to get rid of this one, right? You don't need this value anymore. There you go. There's our game state, guys. It's got fucking everything in it. We have a dictionary now that contains all the data for our entire fucking game. So Pet says, Python has no data types, but sometimes it wants float64. Gator says, Vencabot, have you worked professionally as a programmer, trying to become a web developer by the end of the year myself? Okay, well, yeah, I think Python's really not the most robust web development language. It's definitely usable in web development. In fact, I think it's pretty cool. But yeah, you probably want to fixate more on things like HTML5 and JavaScript, right? But no, I've never done any professional programming. I've been paid to do it a few times, but not more like a freelance capacity. Would you kindly go through and comment your code so that people just tuning into your channel can read where you are at for each section of the code? No. But thank you, Zebus. Good idea. Very good idea. But I could do that, but it would take a lot of time. I think for now, I'm going to be mostly not doing that and just trying to review more often. If you go to our GitHub page at github.com/Vencabot, you'll find that for season 1, what I would do is I would go through at the end of the stream, and I would go through and comment the code in 2 varieties, with light commenting and with verbose commenting. Right? We actually have a whole bunch of examples on our GitHub where the code is commented to fuck. Like, you just read the code and learn what you got to know, which is kind of cool. But it was a lot of work as well. I think I'm not going to do that in the future either. The code is hard to write, so it has to be hard to read, yeah. Yeah, I tried to make my code very easy to read if possible, using long variable names and stuff. But I think I don't want to go through and comment, to say everything that's going on for total beginners. If I tried to comment the code for total beginners, it would be probably more comment than code. So I'm just going to have to assume people are watching. Not yet, Zebus, no. What we've done is that in the past, I uploaded the entire season 1 of Intro to Python. So basically, this show has multiple seasons. Every season is 6 episodes. And in those 6 episodes, we start off as total beginners and end as intermediate level programmers. Right? So in the first season, we started off not knowing what a variable even is, and we ended with having a working version of a Pokemon battle where you can define your own moves and your own Pokemon. It's kind of fun. And season 2, we did a Zork-like adventure game where you can like pick up torch and go explore a cave, and that's kind of cool. Started off again with what is a variable, what is a function, what is an if block, and then at the end we had a fully working adventure game engine on 6 episodes. And halfway through season 2, I sort of lost track of GitHub. So really we only have 1 full season on there, which is the Pokemon season. But it is very, very deeply commented. I recommend checking it out if you guys want to learn about programming, and you want to learn a bit faster than we are doing it here. I'm kind of taking my time with this. But if you want to learn faster, go read some code. That's at github.org, or is it .com? GitHub/Vencabot /intro to Python. We have all kinds of cool stuff there. Thank you, Rico. Maybe I should, huh? Maybe one day. Okay, so we have this dictionary. We defined it right here. And then we saved all these values into the dictionary instead of as standard variables, right? We don't have these variables like monster name. That doesn't exist anymore, right? Instead, we have this dictionary game state and it has this key, which is a string monster name. Right? We changed the way that our code is laid out. We're not using standard variables anymore. We're using one big game state, and it's a dictionary, and it has all these values in it at these key addresses, such as the address monster name. Likewise right here, right? We don't have this anymore. We actually replaced this now with just very simply a string game state monster HP, right? Here we go. I'm gonna probably, oops, I'm sorry, I think I'm using Vim here. I use Vim in my day-to-day life, so I want to use like Vim commands. That doesn't work. Let's do a little line break. Okay. Let's do a hanging indent there. We usually like to use 8 spaces for hanging indents. 1, 2, 3, 4, 1, 2, 3, 4. There you go. We're going to add in this other string. I wish we could use f-strings. We'll probably use f-strings in like our episode 6 for this season. Because I love f-strings. This is really sloppy. I don't like these long concatenations. But so for beginners, we'll just use all these pluses for now. Okay, then we also have the, game state protagonist name. Right. We're going to add in the string version of the game state's protagonist HP. Right, so we're not accessing the variables directly anymore, right? Before we were accessing them directly by name. Now we're accessing them, accessing them as keys in a dictionary. But it behaves very similarly. It's just that now they're inside this other thing. There's another layer of encapsulation, right? They're kind of enclosed in something. Glad you guys are enjoying it. So I really enjoy teaching Python. Like, for me, Python is really creative. Really satisfying. And my goal is to try and take people that might be scared to program otherwise and show them just how much fun they can be. Okay, so we've got this dictionary now. It has all these cool values in it instead of having raw variables. But what's really cool about this is now we can finally use it to make our code more clean. In fact, by the end of our stream today, this big, deeply indented block of code, look how deeply indented, look how sprawling it is. It's kind of hard to scroll through it real quickly and see how it works. Right? That's our problem here. And as we become more capable programmers, we can break up our code into more understandable chunks instead of having it just be one big, nasty string of commands, right? So for instance, up to this point, if you attack, it says, hey, if they want to attack, then run this stuff here, right? But, oh my god, guys, because our game state is now one big object, why don't we go up here and just say def turn attack? We're going to make a new function called turn attack. It's going to take one argument, which is, game state. Let's go down here and copy paste our code. We're going to copy this code and paste it over. Right? This is the attack code, right? If they want to attack, then run this code. Fuck that. If they want to attack, run this function. Right? And look at this. For one thing, this is, if we copy paste the code, right? It's actually indented by 8 spaces. 1, 2, 3, 4, 1, 2, 3, 4, which makes this one scroll off the edge of the screen. That sucks. But that's because down here, we are nesting an if block inside of a while loop. So it has to be indented by 8 spaces. Makes sense, right? Because it's nested within 2 blocks. However, if we move this code to a function at the top of our program, then we only need 4 spaces. Right? So now we can use this as a way to make our code less deeply indented. Of course, on the other hand, we have these this game state variable now, which we have to reference data explicitly from using keys. That's kind of a pain in the ass. In the future, we'll probably change all the f strings. Maybe even on the next episode, because this is kind of a pain in the ass. These long ass string concatenations. But for now, we're gonna do it this way. I'm not gonna use f strings or formatting yet. There you go. Then we're gonna use we're gonna say here game state. Oh, I should probably talk about this now. Let's talk about this before we end the stream here. Monster HP equals game state monster HP. I actually put these in parentheses here so we can get a line break. So in Python, line breaks are significant, right? So we cannot do this. If we did that, it would crash Python, because in Python, commands end on a line break. So it'll be like, yo, what is this command? Why is it indented so deeply? Right? Why is it so deeply pushed in by spaces? What the hell's going on here? But you can actually do these kind of line breaks with a hanging indent by simply using parentheses. Right, let's do like this. Right. So if Python sees like an open bracket of some kind, whether it be a square bracket or it be a parentheses or it be any kind of bracket, then you can break lines inside and have it not crash Python. So by doing this, we can do that. Okay, let's also get the game state. Protagonist attack power. There we go. We don't need this line anymore. We're getting away from this whole monster HP text thing. We're just going to use... we're going to use the string version. Right? String of game state monster HP. I'll show you guys why. So it might seem like kind of a pain in the ass right now to use all of these dictionary keys instead of just having it be a variable name, right? But I'll tell you why that's important that we do this. Okay. Okay, so the reason why we are using this game state as sort of our mediator for all of our data calls right now, all of our data fetching, instead of just using the straight up variable name like monster HP, we're having to use game state at key monster HP. The reason we're doing that is because it allows us to have all of our turns take the exact same argument. Def, turn, defend, game state, right? Whereas before, every function would need to have different arguments. They would need access to, maybe this one needs the player's name and his HP. This one needs the player's name and his attack power, but not his HP, right? So by having all of our functions take the same argument, tomorrow, or should I say on Friday, next Friday, we can actually automate things like turn taking, because no matter what function we call, we know what argument it takes, which is game state. So that'll allow us to swap things in and out more freely, and you guys are going to get your minds blown when you see how much more powerful that is in the long run. Right now it looks kind of funky, right? All these game state calls, it's kind of a pain in the ass. And if I was another kind of programmer, I might call this GS. Right? For this very reason, to save screen real estate. But in my opinion, having it be more explicit what it is probably better in the long run. Right? You can save screen real estate by giving things short names, but if it loses its meaning for new programmers that are reading your code, that's probably not a good thing. Rico says, one thing I've always been confused about in Python is spacing. Does certain spacing close code blocks? Yes. Or define code blocks? Yes. Yes, indeed it does, Rico. So basically, I'm going to go demonstrate something real quick for Rico, since he's a personal friend of mine. We're going to take a step away from our code here for a second. So basically, let's review code blocks real quick. I'm going to say here, Rico is demand. And that's true. We're going to say here, if Rico is demand, then we're going to say, print off, Rico's that guy. Well, at worst, he's all right. We're going to say down here, print, that's how I feel about Rico. Big feelings about Rico. Mad feelings right now. So, in Python, in Java or other languages, right, you would use something like this. You would say, if Rico is demand, you would end with another bracket. Or like an end if. Other languages use like end if, right? Things like that. But other languages use curly brackets. You would end each line with a semicolon. And what this will tell things like JavaScript, it says here, this is where the block starts. Here's where the block ends. And here's where the command line ends, right? Every command has a semicolon. That means it's a new command. And what's cool about that is that you can have it all be on one line in JavaScript. Or you can have it like that if you wanted to. And it'll still know how to run, because it knows that when you have the open curly bracket, that's when you're starting a new code block. And when it's a closing one, you're ending the code block. And it knows that every command ends in a semicolon. So the lines and the spacing is not important. It's not significant. However, in Python, it's different. Python says, hey, fuck your curly brackets, fuck your semicolons. In fact, most languages encourage you to indent anyway. In fact, if you read someone's code, it'll look like this probably. If you read some stranger's code, it'll be like that, right? Because indenting is good, it makes it easier to read, right? Python says, well, listen, if we're indenting anyway, why not just make the indenting and the line breaking important to the language? So they say code blocks begin with a colon, and then you indent each command in the code block, and then for every command you get a line break, and then you end the code block by stopping your indenting. Right, that's to answer Rico's question there. So yes, so when you start indenting, Rico, that's when your code block starts. Yes! And once you've stopped indenting, then that's where your code block has ended at that point. Right, that's how you, so the indenting really does define where the code blocks start and end. Yo, thank you, Buck, for the biddies. 10 times better than my intermediate Python professor ever was. Dude, thank you, man. That goes a long way. That $2 is, oh shit, I might get banned from Twitch for saying that. Dude, we cannot, it's not in our, it's in our contract to never, ever compare bits to money. But guys, 1 bit is approximately equal to 1 cent. Don't tell Python I said that. But basically, don't tell Twitch I said that. But yeah, so basically 200 bits is like $2. I can go buy some food with that, man. Thank you. That's some sandwiches right there. That's a couple tacos. But yeah, so in Python, you begin indenting your code, and that defines a code block. And when you stop indenting your code, then you've ended the code block. And no, Rico, it does not matter if it's 2 or 4 space or 8 or 6 or 10. As long as basically the line after the indent, or the line after the colon, right? If or def, right? You know, def, you know, functions are also code blocks, right? Some argument, right? You know, do this shit, right? And this, right? So if you have this stuff inside your function, the code block's indent level is defined by the first line after the colon. So we can do it like this, or like this, or even just with 1 space, like that. But we cannot do like this. We cannot say, you know, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, right? That won't work because they have to all line up with the first indented line of the code. We can do this though. We can do this, right? You can have different levels of indent for each function because as long as every block is internally consistent with its indentation, that's fine. However, guys, don't stop watching right now because Python has what's called PEP8, and PEP8 is a style guide that says, yeah, these things might work in Python, but please don't do them because as a community of programmers, right, as guys that are, you know, we're co-workers, we are, you know, we're friends, we're working together on a project, it's important to have one style of code to make your code easier to read by other Python programmers. Right, so some things might work technically, but PEP8 says, here are things you should do and things you should not do, and in PEP8 it makes it very clear, please guys always use 4 indents for your code blocks, right? And if it's nested in, then do 8. If it's nested in deeper, then do 12, right? Always indent in groups of 4, plus. But to answer Rico's question, no, technically you don't have to use 4. Python will read any level of indent as long as you're consistent inside that code block, but don't take advantage of that, guys. Always use 4. That's a PEP8 standard. So that's what we're doing here, guys. Using, like I said, we're indenting things by 4. We're indenting hanging indents by 8, if I could remember. Right here, I forgot. Right here as well. There you go. Okay, so cool. Right here as well, so you need to have more indent. No, this is actually already at 8. I'm sorry, I'm stupid. Okay, so we have this use spear code here. This is the old code. We have this attack now, and we have a turn defend. Let's go copy paste our defend code. Defend's pretty simple. It just turns this flag from false to true. So when you defend in this game, guys, it changes this variable, player is defending, from false to true. Right? If we go down here to the opponent's turn, the monster's turn, it says here, monster name, burninated, protagonist name. So, you know, Trogdor, burninated, strongbad. Right? And then it says, if player is defending. So, if this is true, then the protagonist loses some HP that's half of the monster's attack power. So the monster has 6 attack power right now, right? He's going to lose 3 health because that's half of his attack power. But if the player is not defending, then the protagonist loses the full attack power. Right? So we're using a Boolean flag here. That's to say a true or false value. If player is defending, then they only lose HP equal to half of the monster's attack power. But if they're not defending, then they lose HP equal to the full attack power of the monster. Right? And that flag gets changed right here. Right? If they're defending, that becomes true. And it's a start every turn, right? When a turn starts from scratch, like the back and forth starts again, player's defending becomes false. So the player gets a turn, and the monster gets a turn. Then once the player's turn again, this flag gets flipped back to false. So now it's a new turn, the player is not defending anymore, and then he can choose to defend right here. If he does, that flag becomes true, and the monster's attack power gets reduced on its turn. So let's go copy paste this code now. Right. You're going to see why I'm doing this, guys, in a second. We have turn defend here. It takes a game state as its only argument. That's all the data it needs is inside this game state. And now we can actually indent it less deeply because we're not inside that nested if block anymore. In fact, in PEP 8 says you should put 2 spaces between top-level functions, or 2 blank lines. Make it a bit easier to read. Let's go follow PEP 8 like that. Okay, so we're going to say here, the game state has a key called players defending, and make that true. Then print off the protagonist name. We're going to fetch from this game state dictionary, because it contains the player's name and everything else about the game. And print off, they raise their shield. Right, now, I should talk about something here real quick, guys. This is the time to discuss this. I'm going to read Signot's message first, though. I'm already grumpy because it took me like an hour just to delete my 2DS account and get another one. Yeah, Nintendo is not really super on point with their account management and their online, friend list kind of stuff. They're kind of whack with that kind of stuff. But, it's, you don't have to do it all that often. So I'm glad you got through it, Signot, anyway. All right, guys. We got to talk about mutability. Let's go to our notes here. Here's our notepad, our notes. Right. It's time to have the mutability talk. I hate talking about this. It's kind of a drag to discuss with totally new programmers because it's kind of an abstract idea. Basically, some data types are immutable, right? They cannot be mutated. They are, once you define like an integer, let's say you define the number 1, it will always be 1. It cannot ever be changed. It cannot be mutated, right? Other data types are immutable. They can be mutated, right? Now here's why it's kind of hard to explain mutability to beginners. Because let's say that we have, let's go to our little example code here. We're gonna put a comment here. In Python, comments are lines, in any language, comments are lines that are ignored when the program is running. So you can use these lines to write messages to your fellow programmers. So you're gonna say here, a comment, we're talking about mutability, right? So Python won't read that line. That way we don't have to use like Python syntax. We can use English syntax. There you go. So we're gonna say here, this is not an example of mutability. And that's kind of confusing. We're going to say here, our value equals 1. Print our value. Our value equals our value plus 1. Print our value. So what's that going to come out as, guys? What do you guys think? You guys are pretty smart, right? You guys know what it's going to be, right? It's going to print off 1 and 2, obviously, right? It prints off 1, then it prints off 2. So we're saying here in the second line, the second assignment, we're saying our value equals whatever our value was plus 1. So now the new value for our value is whatever it was plus 1. So even though these two lines are the same, print and print, they're the same exact line, right? We get two different responses. And to a novice, like your first day programming, it might be kind of weird, right? Because you might not understand the way program flow works, where, the same line might do something different later in the code, because these all happen in order, right? It sounds obvious, but I've had newbies here really have trouble with that in the past. So this line happens, we assign the value of 1 to our value, and then this line happens. And then here we change our value's value, right? We change what its value is. And then we do the same line, because it happens later, something different happens, right? It prints off 2 instead of 1. That all makes sense to you guys, right? You guys are pretty well educated by now. However, here's what I want to point out, right? This is pretty important. This is pretty important. Can't type. You know, our value did not mutate. It did not change, right? That seems totally counterintuitive, right? Because here it was 1, and here it was 2. So it changed, right? It changed. Wrong! Right? In the second assignment of our value, we made a whole new variable. And it just so happens to have the same name as a previous variable. Right? I misspelled variable here. Right? That's very important to point out, that our value did not change. We just got a whole new thing back, right? We got a whole new thing with the same name. Now, why is that important, right? Well, integers are not mutable. They're not mutable. They can't be changed, you know. Once they're made, they can't be changed. A 1 is always a 1. Right? A 2 is always a 2. You can get new integers by, you know, doing math. You know, 1 plus 1 will give you a new integer back. I'll give you 2, right? But you cannot change that integer. Now, all right, that's, once you put it that way, it's not that hard to understand. You know, you're getting something new. You always make something new, right? Wrong! Right? But there are data types which do change. And the way that you use them is actually somewhat different. For instance, let's look about, you know, let's look at a mutable data type, such as a Dict. We can say here, you know, our Dict equals, you know, empty dictionary. Let's put something in there. Let's put, you know, we'll put apple red, right? Right. Here's this dictionary. It says apples are red, and then print it off. Our Dict. Then we can say here, our Dict banana equals yellow. And then print it off again. Right. Let's see how this happens. What happens here, guys? Let's run it. Okay, so we print off 1 and then 2. Then print off apple red, and print off apple red and banana yellow. Okay, so these two situations look very similar, right? We say our value equals 1, we print it off. Then we say our value equals our value plus 1, we print it off again, right? But that's we printed off 2 different values, right? It's not the same value that was changed. They were 2 totally different things. They just happen to have the same name. Right? So here we printed off 1 integer, and here we printed off a whole nother integer. Whereas down here, we have this dictionary, right? We printed it off right here. And then we added a key to that dictionary, and then printed it off again. Unlike in our first example, this is not a whole new dictionary. This is the same dictionary. It has just been changed. Right? We printed off the same dictionary twice. It's just that on the second time, it had something added to it. That's true of lists as well. They're also immutable data types. Integers, strings, floats, Booleans. Those are immutable data types. They cannot be changed. They can, however, be added together. They can be compared, and those things will give you back a new piece of data. And you can call that data by the same name that the old data was using, but it is new data. Whereas you have things like lists and dictionaries and objects, and these things are immutable data types. That means that you can make them, and then you can change them. And it's still the same thing, it's just different now. Now, why is that important? Why are you bringing that up now? Right? That's because in our code right here, we talked previously about how functions, you put data in using arguments, and you get data back out using return values, right? Like right here for our useSpear function. We defined a bunch of arguments that bring data in, but to get data out, you have to return a value. And that's because data that you make inside the function cannot be used outside of that function. Right here, it may appear that we are updating the monster's health when we use the spear, right? Monster HP equals whatever the monster's HP was minus the protagonist attack power times 2. So when the player uses the spear, they throw it, right? It deals double their attack power in damage to the monster. Very easy to read, right? Monster's health is whatever it was minus the protagonist HP attack power times 2. So we are updating this variable, right? Wrong. That's what it looks like, and of course that's why it's so hard to understand for beginners, even for advanced programmers, because it's so clearly that's what's happening, right? We are updating the monster's health. But programmatically speaking, in Python, we are making a brand new value that's using the same name, monster HP, and what we're getting back is a brand new value. So to use this outside of the function, we have to return it, because any data that you define inside the function goes away when that function ends, unless you return it back out. So here we are returning this new monster health to get it out of there, because it's not the same monster health that was fed in. It's a whole new thing, right? So sure, from the outside world, they fed us in the monster's current health, right? And we feel like we updated it, right? But that does not mean that that value was updated outside of the function, because outside of the function, it was a whole different value, right? It was not the same integer. We have a whole new integer now. We have to spit it back out, because anything you make inside a function cannot exist outside of that function. So we're bringing that up, guys, because right here, turn defend, our defending turn, we have this this Boolean flag right here, right? The game state is a dictionary, and it has this key in there. Player is defending, and it's probably false at the start of the turn, right? And we're making it turn to true. Now, if this were an immutable data type, we would then say down here, return, player is defending, right? Let's do it like this, right? Let's just say we changed our function to say something like, player is defending, right? And we said here, if player is defending, right? If they're not defending, right? If not, player is defending. Then we're going to say here, player is defending equals true. I'm sorry, I'm going to read your message here in a second, King. I apologize. I'm getting a little bit sidetracked here. Immutability is so important, guys. It's kind of hard to understand. I know, trust me. So if this were, the way that our code was working, as it, has in the past, what we're doing here is we are getting an argument called player is defending. That's our argument, right? It's a Boolean value. That's immutable. That cannot be changed. We're saying, hey, if they're not defending, then make a new value, make a brand new value that has the same name as our argument, right? This is a whole new thing. Make a new value called player defending and make it true, and then return it back out. That way, the outside world can know whether or not the player is defending now, right? We ran this function, something has changed, right? Usually in a function, something will change, and we're going to take the data in and then spit out some new data. That makes sense, right? However, when you're using things like a dictionary, that's a mutable object. So why is that significant? Right? This is different now. We're actually using data that can be changed. Right? That means that we actually don't have to return any data, because in the outside world, this data has been updated. We fed in a dictionary, and inside of our function, we changed that dictionary. And because it's the same dictionary we were fed in, that means that outside of the function, it also was updated. It's the same dictionary, right? It actually has mutated. We took it into our function as an argument, and we mutated it. That means that, permanently speaking, that dictionary is different now. So for that reason, we don't return any data, because we're not making a brand new anything inside of our function, right, to return out. We're actually changing something that we were given. So like Rico saying in the chat there, I just kind of glanced down, we're talking about object-oriented programming versus functional programming. And we're going to talk about that more in our next stream, because it's going to be about classes and stuff. But it has its pros and cons, guys. One of the pros is that we don't have to return any data, right? It makes our code a little bit neater. It makes our code more comprehensible in some respect, because instead of making new data by the same name as other data and kind of using it the same way, we are instead literally updating the data. We are changing the data. We are taking some data that exists and we are mutating it. It is immutable, right? So here we are. We're taking this game state dictionary and we are changing the value that it has at players defending to true, right? And because the game state is a mutable object, that means that when the function's over, that change still persists because it was not something we made inside our function, right? Things you make inside the function will go away, but we didn't make this in the function. It came from outside, right? It already existed. We're just changing it. So for that reason, guys, we're probably not going to be using a whole lot of return in the near future because now we're not changing values and then returning new data. We are actually messing with this game state that exists outside of our function. So now return is kind of pointless for us anyway. I'm sorry. So Sigam says, oof, wait, when's Minecraft starting? In about half an hour, probably. Probably going to need a little bit late start here as I continue working on this program. I'm having a lot of fun here. The King says, hey, can I learn programming to create a video game? Just saying with all these non-coding games, engines, and tools. Yes, the King, indeed. Every game engine will require a certain amount of programming. Right? Even things like RPG Maker, which are very, very simple, still require a little bit of scripting. But there are tools out there for sure that will really let you make games that can be really fun without having to know barely any programming, for sure. But I do recommend learning, though. It's a lot of fun. Exactly, Rico. So we mentioned earlier in our stream, guys, that for now, we are assuming as beginners that this game state is the new Christ, right? Having all of our data in one big object that we can manipulate has benefits. For one thing, it allows us to use the same argument for turn attack and turn defend. It makes it very clean. Right? Very, very clean. It's the same argument, and even though both these functions need different things, they get everything they need from this one dictionary. It has everything, right? This dictionary has everything you need in it, so that's kind of cool. Also, it means no more return statements, right? Because now we can just change the data, and we know that it's changed. It's changed everywhere. That's kind of cool. But like Rico says, we're going to learn next time that this approach using immutable data, a lot of programmers really hate it. A lot of guys out there are really strict about not using mutable data types because they can cause problems that are called side effects that will add bugs to your code, and people fucking can't stand it. So you're going to find a whole gradient of programmers out there who some really love using mutable data types. For them, it's like, you know, the best thing ever. And other guys refuse to use them because of the downsides they might have. But for now, guys, we're going to be assuming that they're just great. Next time, we're going to talk about the downsides of them for sure, next Friday. But yeah, so we have turn defend now. That's great. And now we're going to add in, you know, def turn item. Right, so take the game state like everything else. Right, this big dictionary has everything in it that we need. That's really convenient, or it's very convenient. We have one big dictionary that's everything we need inside of it. No matter what it is, we know it's inside that game state, so that's great, right? Right? Maybe not next time, right? Maybe not for next week. But anyway, for right now, it's great. Let's go down here to our use item code. Right here. And then copy all this shit. And paste it up here. To use a turn item. Yeah, Rico's not his first time around the block. He knows that there are definitely some downsides to doing things this way. But for now, trust me, it's great. We're going to unindent all this code. There's probably a way to do this using idle, but I don't care. Just do it the old-fashioned way. One line at a time. Oh man, this is a lot. I'm realizing now this is kind of a lot. That's all right. Before the end of our stream, guys, we're going to be using our new dictionary, game state, and using function definitions to make this code a lot simpler. So it might take us a little bit longer than I was hoping for to end this stream. That's fine. We're learning a lot, right? It's worth it. We're going to be playing Minecraft all night here, guys. Come play with us, guys. You guys have Minecraft on PC? Come play with us. It's going to be starting at around probably like 9:30 Eastern time. Right now, it is almost 9 o'clock. Oh, I love it. I love it. So the King says, are there still a lot of jobs in programming? Yeah. Also, is the skill still useful in game development? Yes, definitely. You have to be able to program with King, unless you want to do, you know, artwork or music or something. Yeah, obviously. I shouldn't say obviously, but yes, indeed, sir. Programming is definitely key to game development. Exactly, I totally agree, Rico. Yeah, both are fine. Object-oriented and functional. In fact, my stance is that you have to find a balance. You can't just use one or the other. If you use either object-oriented programming designs, philosophies, or functional programming philosophies, you're going to have problems. You need to find a way to strike a balance. Let's go, Signopt. Your text editor is driving me a little bit nuts, huh? What do you use, Rico? Okay, so we have this turn item that uses the game state, right? That's great. But here's what we can do now, guys. Why don't we go down here to our main body of code for the player's turn and see how moving all of this complexity away from the main turn block, you know, all this turns happening here, we're kind of trying to divide up the complexity. So instead of having it all be in this one big tower, right, this one big nasty tower, we divided it up here into discrete functions. We're going to break this one up. This one's pretty complex, right? We're going to break that up into functions too. By doing this, we can go down here to our turn code and make it way more clear what the fuck is going on. We're going to say here, first we're going to say here, change this to the game state, right? We're going to say here, game state, player is defending, is going to be false at the start of the turn, right? Every turn they're going to stop defending. Then we're going to say here, if the player's choice is attack, then run turn attack with our game state. If they wanted to defend, then run turn defend with the game state. If they want to use an item, go through all this shit, backspace through it, then say run turn item with the game state. And before the end of our stream, we can make it even simpler, believe it or not. So yeah, so basically, our code's way simpler. It's way easier to understand now, right? We're saying, hey, if they chose to use attack, then call the attack function. If they chose to defend, run the defend function. If they chose to use an item, use the item function, right? And if we want to know what those do, we can now scroll up and find out exactly what they do and how they work. But we're going to break up even more, right? We're going to say here, instead of saying, we're going to say here, for inventory in the game state, right? The game state's player inventory value. Print off every item you have. Right? Then we're going to say here, if the item they want to use is a spear, then don't run all this nonsense. Just run a function. Right? Just say, item spear. Right? Function. It's going to take the game state, like everything else. Everything takes the game state, right? It all takes the game state. So now we can go down here and we can delete all this code, or hypothetically speaking. And then just do that for every single item, right? So make our code a little bit cleaner. Let's go down here to our use spear, for instance. And I'm actually going to copy paste this for now. Copy that. Go down here to use spear and paste it right there. We're going to say here, if the spear is in the game state, player inventory. We're going to only take the game state in now, right? Let's delete all these arguments and only take the game state to simplify our arguments. Then we're going to say here, if they have the spear, then do this. If they have the spear, then run this code. We're going to say here, update the monster's health. We're going to say it's going to be, game state, monster HP, minus the game state's protagonist attack power times 2. There you go. Cool. We're going to print off, the protagonist's name using the game state, because it knows the protagonist's name, right? We don't know it, but the game state knows it. We can just ask it what that is. And plus this other string. plus, you know, the monster's name, which the game state also knows. We don't know it, but the game state does. We know the game state, so that works for us. Sweet. We're going to print off, you know, the monster's name and his current HP. That's fine. Print off the game state is monster name. Like that. Plus, you know, the monster's HP is a string. Okay. There you go. Just like that. I want to use Vim commands, but I can't. Okay, you don't got to return anything anymore, because we actually don't have to return the monster's health, because we actually updated the monster's health right here. We actually updated it right there, so no more of that nonsense. But we actually have to indent this deeper, don't we? There we go. There we go. Print off a blank line. That's fine. Then we can say here, you know, else. You know, if they don't have the spear in their inventory, we have to remove it too. We're going to say down here, you know, game state player inventory. You know, our inventory. Remove the spear. We just used it. It's gone. Cool. Otherwise, we're going to say here, you know, print off the protagonist's name using the game state. The game state knows what the name is of the guy we want. That's cool. And then the rest of the message. Sweet. What am I missing in the chat here? Let's see here. I use Sublime. Okay, versus Code. VS Code's all the hotness, though. Yeah, visual. Yeah, what's VS? Isn't that visual something? Signop says, I think I'd be better at game design with characters, sprites, background, etc., rather than game development, huh? Yeah, graphic design related, exactly. You can draw stuff. Who is she playing? Who else is playing Minecraft later? I think maybe Mexi, maybe Faust, not exactly sure. But everybody's welcome, though. Everyone's welcome. All right, so now we have this use item spear, or is this called item spear function, and it, you know, uses the spear basically in this nice little block of code. It tells you everything you have to know about using spears, right? So now up here for the spear stuff, we can just get rid of all this shit. Like that. Cool. And same for using the toilet paper, right? We just copy all this code and make a new function called item roll of toilet paper. Takes the game state as its argument, and then here we're going to print that off. Not sure why it's indented so deeply. Might have some syntax errors here somewhere. I probably do. Probably have a. Make sure like all these things are all my. As I can't, doesn't tell me where the begins and ends. That's fine. Let me double check and make sure I have all these closing parentheses that I need here. I think that I do. Right here I don't. There we go. There's your problem. Visual Studio, Visual Studio. I don't use though, but I might switch. Huh? Visual Studio. Lesson says, you making a hello world? LOL? Yeah, kind of. Pretty basic stuff here. Not totally basic. We're halfway through the season, right? We've learned a lot by now. But go back to our season 1 episodes, or excuse me, our episode 1 episodes, and you're going to see stuff that are more hello world oriented. Okay, so we're going to say here, you know, if we have this toilet paper, right, then do all this stuff, right? Print off, you know, the protagonist's name, which the game state knows. That wasn't an argument, right? That was not an argument. We don't know what the player's name is. But we do know the game state, and the game state knows what the player's name is. We can just access it that way. In fact, the game state knows all. So it's what makes it kind of cool, right? It's kind of a cool argument to have, because it tells us everything we have to know about the game. Which can have its downsides later on. But for now, that's great. It has all the data we need, including the monster's name, the player's name, everybody's stats and stuff. What could be greater? Than playing a game of golf with a gator. Gator golf. Alright. If they don't have the TP, that's fine. Just print off, you know, we don't have that shit, dude. Also fine. You don't always need to have TP on you at all times, but it probably helps sometimes. That's for damn sure. Awesome. So what we're doing here, guys, is we are taking our old monolithic giant tower of code that was kind of hard to scroll through and understand what was happening, and we are breaking it up into discrete functions. So everything that's happening here, like using the spear, using the TP, is going to have its own function now. That way, it's pretty easy to understand what's going on. You don't have to scroll past a bunch of nonsense to see the overall program flow. And if you want to learn how a role of TP is used, which is pretty important for most people, I think, you can go to the function and read it without having to, scroll a million spaces to the right. It's so deeply indented, right? Now it's just indented as a function. That's kind of cool. So let's carry on then with these items. Let's go to here, that's our spear. Let's delete all this code now and just say, hey, listen, if you want to use a roll of TP, then just run item roll of toilet paper with the game state argument. And there you go. That's your turn for using your toilet paper. Awesome. Let's do something with the potion, right? We're going to be almost done here for tonight. Let's copy paste our potion code and put it into a new function. We're going to be calling item potion. We're having our standard we're designing here. We have like a standard, right, where all the basic turn functions are called turn and then the name of the turn, like defend or item, and all the items are named item and then whatever the name of the item is. It's kind of like we're kind of using like a standard there to make it easier to read. Here's item potion. Let's paste our code that we stole from above. So here's the potions code, right? We're going to change how it works. We're going to take in a game state argument for this function. We're going to say here, if the potion is in the game state that we got, the player's inventory inside of that. The game state has the player inventory in it now. There you go. We're going to update the player's health right here by updating the game state, which is a mutable object, so it actually gets updated, permanently. Nothing has to be returned. We're not making a new data type called protagonist HP. We're actually updating the dictionary. So that's cool. Saves us a little bit of trouble there. No more return. It's just very simply changing the data in the dictionary. That's cool. This line here, we've actually stopped using these HP text variables. That was, again, for beginners who I wanted to make it more explicit how the string function worked. But fuck that for now. We're actually pros now. We don't need that crutch. Just makes things harder to read overall. I'm going to unindent all these lines here to their proper depth. We're going to say here, print off the game state's protagonist name value, right? And then print off the game state's protagonist name value, followed by HP, followed by his the player's HP, like that. Cool. Awesome. Then we're going to remove the potion from the inventory. Right? We're going to say here the game state's player inventory value. Remove the potion from it. Sweet. Is there no way to create a global variable in Python? There is indeed, DJ. Yeah, there is indeed. In fact, it's not even that hard. But right now we're going to be doing it more explicitly with arguments because globals are the devil. Never ever use globals, guys, in Python, ever. Some languages, you kind of have to use globals. In Python, never use globals. That's not a good idea. We're essentially making like a bootleg global, right? That's why DJ Isco asks that. Because we're passing in this argument to all of our functions as though it were a global. And by global, I mean a variable, guys, that can be accessed anywhere in your code and can be changed anywhere in your code. Right? That's what a global is. We're essentially doing that by making this game state dictionary that has all of our useful data inside of it. So it's kind of like a global. We're using it everywhere, right? We're using it globally. However, the reason why we're not going to make it global is because in the future, we're going to probably want to have more control over what data goes into and out of the game state. So it's always a good idea to use arguments. Don't ever use globals. Or it's possible to reference game state without passing as, yeah, there is a DJ. It would be a method, right? If we actually add these all as methods to our game state object, then we could not pass it as an argument, right? It's kind of cool. We're going to talk about more about classes and methods and attributes in our next Friday stream. But for now, we're just using raw functions, no methods if possible. But yeah, that'd be one way to do it. We could do it like this, right? We could say game state, item potion. Right? That'd be one way to not pass an argument to it. We talked earlier about how methods always get their parent object as an argument, essentially. Yeah, in Python, I think you can do it. I think it's, for one thing, you could actually just define it up here. If you define it up here, then all the functions can just use it. That's one thing, kind of like how JavaScript works, right? But you can also do it explicitly, I think using a global keyword, yeah. So I could define a global inside of a function, and then it would actually be a global everywhere. But yeah, it's kind of like JavaScript as well. If you define it before you define your, functions, I believe that you can use them. I'm almost certain of that. All right. So let's see here. I'm going to go here to our potion, right? And finish up this code down here. All right. So yeah, blah, 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 blah. Here's the else statement. We're going to say here, if you don't have a potion, fuck you. Say, you know, the game state, the protagonist's name, plus, you know, you don't have a potion. You broke bitch. Okay, cool. Here's the TP, already got that one defined. Now we have to define, just the thumb drive, right, I think. And we'll have all of our functions, all of our items, broken up into functions. I see that all of our functions end with this print line. So why don't we just get rid of all these print lines, and then just have that happen elsewhere? I'll do that at the end of our stream here. So there's our item potion. Let's go up here to our item use, or our use item, and then say here, if it's potion, then item potion game state. There you go. And here's our thumb drive. Right? It only has one. All it does is print off this message. Very, very simple. We just copy that. Go down here. We'll add more usage of that later on. Say def item thumb drive. Give it the game state. Doesn't really need it though. We're just trying to make it more uniform. Every function takes the game state for now. And then we're going to print this off. No one can ever know what's on this drive. Right. Very, very simple. Doesn't even ask you if you actually have it or not, which is fine. So let's just then replace this code up here. Make sure we're following PEP 8 by putting 2 blank lines between all of our top level functions. Up here for return item. If it's a thumb drive, then just say here, item thumb drive. All right. I see we have actually a dash there, so I'm gonna call it like this, and change the name down here too. Okay, thumb underscore drive. So finally, guys, before we try this and see if it actually works at all, I see that we have a lot of redundant print statements here. You know, print a blank line, print a blank line, print a blank line. It always happens after your turn is over. A blank line is printed, right? If that's the case, then why don't we just go down here to, where we have our player's turn, and then just print a blank line at the end, like this. There you go. So I can go through and delete all these extra blank lines we've actually had up here. When the player's turn ends, it's a blank line, right? So here we go. Here's the player's turn. There's the blank line. Let's go up here and delete all these other blank lines. It's just way too many lines being wasted. Very redundant. Okay. Okay. All these post-turn blank lines. There you go. There you go. Here you go. Item spear. Don't need that anymore. Don't need this anymore. The blank lines, the whole purpose of them, guys, is to make it more easy to read. I'll show you guys what I mean when we test the game here one last time before the stream ends. All right. Here's some more blank lines. You raise your shield, you get a blank line. Nope. Attack, get a blank line. Nope. There you go. All right, so now our code is way, way, way cleaner than it was, right? Because now it's more broken up into readable sections. So now we can read this code as such, right? You can go up here, and you can say, okay, we have the attack turns code. This is how the attack works, right? That's how the attack works. Here's how the defend works. Here's how using items works. Right? Here's how using the spear works in particular. They're all in their own discrete functions now. They're not all just one giant tower of bullshit. It's kind of hard to understand, you know, how it's organized. It's not organized very clearly. Here's how the roll of toilet paper works. Here's how the potion works. And finally, here's how the thumb drive works. Now once we define all of our functions, here we define some of our values for the game. Right, here's the game state. We add a bunch of stuff to the game state, like this. Okay. Then we print off, you know, this is where the game begins. We print off, you know, how much health each of the characters have. Then a blank line. And then finally, here's our actual turn code, where the actual combat happens. Right. At the start of every turn, the game state turns the player, he stops defending, right, at the start of every turn. Then we get asked, attack, defend, or item. And whenever we choose, we run the appropriate function. If they want to attack, then run, turn, attack. If they want to defend, then run, turn, defend. If they want to use an item, then run, turn, item. Otherwise, print off, you have to use, you know, either attack, defend, or item. Right. And the enemy gets his turn, right? There's the enemy's turn. And there you go. Whoever survives in the end gets congratulated. And we have our game. Now, I'm going to try and run this code. And I'm not sure if it's going to work because we changed, anytime you change a lot of code at once and don't test in between, you're bound to have a bunch of typos, whether it be a misspelled variable name, or you forgot to close one of your parentheses at some point. So let's just try this and see what happens. And it might take us a few tries to get it to work. But once it does, we'll have a much cleaner bit of code. Run the module. Oh, well, it's running so far. Let's see. My name is going to be Signopt. Right. And the monster I'm going to face is going to be, you know, science. Science! Okay, see it right here. Right? So on line 109, I'm still using the old monster HP and protagonist HP variables, which we don't have anymore, right? Now all that shit's stored inside of a dictionary. That's down here. It says, while the monster HP is greater than 0, there is no such thing as monster HP anymore, right? We have a dictionary instead. Game state, it has a string that's a key. Monster HP. Likewise, right here, we have this game state, and that has the protagonist HP. There you go. What else are we using here? Okay. Fine. Right here, right? Game state. Monster HP. Right? It's not its own variable anymore. Now it's a part of a dictionary. Likewise, right here, we're using a lot of stuff. Like the monster name, we have to use the game state now. Okay, here's the protagonist name. We're going to use the game state now. Okay. We have this player's defending. That's in the game state now. I'll read your message in a second here. I have someone in the chat here getting a hold of me. We're going to update the protagonist health right here using the game state. Again, these variables are no longer discrete variables. Now they are all a part of this giant game state dictionary, for better or worse. Right now, it's really great, but in the future, it might be kind of a bad thing to have it all be in this one massive object. There we go. Going through all of our old variable names and updating them to reference to game state instead. Okay. There we go. Boy, I'm hungry. This is pretty long. Let's break another line here. I love dropping lines. You guys know that. Alright, this is no longer necessary. This is a line. Print off the protagonist's name using the game state. Okay. Then we're going to add in, you know, his HP as a string. So we're going to use a string function to get a string version of his HP. Oops. Okay, there we go. Likewise down here, we have to do the game over text. We have to use the game state, check his HP, since it's all a part of this dictionary now. Likewise here, we're getting his name. We're going to get the name out of the game state, not out of a loose variable, but it's a variable that's saved into this dictionary. And then we also have this game state. We're going to get the monster name out of there for his congratulations message when he wins. Bastard that he is. Alright, let's use the game state here as well. And there we go. Now this code might work. But it might not work because we changed so much, right? Hopefully you have no typos. So, Walkin' Talkin' Stephen Hawkin says, I'm completely new to coding. Do you think you have come too far for me to catch up on what you have done so far? Perhaps so, Walkin' Talkin' Stephen Hawkin. That's a really sick handle, dude. But here's the thing. If you go to youtube.com/Vencabot archive, or on YouTube search for Vencabot, you'll find me that way too. Just go on there and type in Vencabot into the search bar. You will find our Season 1 of Intro to Python, where we started off, again, as total novices on day 1, episode 1. And we talked about, what is a variable, what is a function, how does programs, how do they flow top to bottom, how does that work, what is the code block. And then over the course of 6 episodes, we started off as total novices and ended with a fully working Pokemon battle. You can make your own Pokemon, define your own moves. It's pretty cool. And so basically every episode we do, we add on new concepts. And we're still very much beginners here on episode 3 of this new season. But even then, by episode 3, we've kind of moved on past some of the most basic stuff that you might have trouble with as a total novice. I apologize, my dude. Yeah, we're already pretty deep into different data types and, mutability and that kind of thing. Whereas you probably need things like, how to define a function, what is a variable, how our program's laid out, where do you start, right? Where do you start? The streaming background, of course. Thank you, Walkin' Talkin'. I appreciate that, man. Welcome aboard, dude. We do Intro to Python here every Friday. And next Friday is going to be even more advanced concepts. We're on episode 4 next week. And every season here is 6 episodes. So our first season is available totally on YouTube. And that's Pokemon. 6 episodes start off total novices, ended with Pokemon working. And then season 2 was an adventure game like Zork, a text-based adventure. Started off, again, don't even know what a variable is. What the hell is a string? Episode 1. And then by episode 6, we have a fully working adventure game engine. Like to walk around and explore a cave, that kind of thing. Here we are on season 3 now. We're doing like a JRPG, like a Final Fantasy or like a Dragon Quest sort of ordeal here in season 3. And we're on episode 3 by now. Like I said, it's a little bit more advanced than episode 1 was. And sadly, I've been kind of slacking about getting that stuff onto YouTube in a timely manner. So really, only season 1 is fully available. I think season 2 is halfway available on YouTube. Thank you for the follow, dude. All right, so I think the game should work now unless we have a bunch of typos. Let's try it. Let's run our module. What's your name, son? I'm going to be Stephen Hawkin. Like that. Walkin' Talkin' Stephen Hawkin. The monster is going to be Vencabot. This guy's an asshole. He's been moving too fast, dude. He's moving too fast. Slow down for these guys. It's already episode 3. We're already so advanced. So I've got 20 health, and Stephen Hawkin has 25 health. Good for him. So I want to have Stephen Hawkin defend against Vencabot. Right, so let's defend first of all. Okay, so I took fractional damage because I took half damage there, so it gave me back a float. That's fine. So I have 22 health left. Or he has 22 health. I'm playing as Stephen Hawkin. I'm actually the bad guy here. All right, now I want Stephen to attack me. Right, attack me, Stephen. Boom. Okay, so we slash Vencabot with his sword. Okay, so I took a bunch of damage there. Cool. Now I want Stephen to use an item. Let's go through and try these out. Let's use the spear first of all. Okay. So he took a bunch of damage. In fact, Vencabot's almost dead. Thankfully, the rest of these don't even do damage anymore. So I lost my spear. That's good. Let's try the roll of toilet paper. Okay, so that worked. I threw the TP at Vencabot, and it wasn't very effective. Let's try... Is that gone now? Yeah, so I lost my TP now. Let's try the potion to heal myself. Oh, we got a problem here. Here's a typo. We're using an old variable here. Let's go fix that old variable in the potion code. Okay, let's see here. Right here. Right, we're not using this HP text value anymore. We're going to be using instead the string version, using the string function to convert this integer, or I shouldn't say convert, right? We get a string back from this integer. Or excuse me, an integer back from this string. Oh, I'm sorry, I got it backwards again. That's fine. You guys know what I'm talking about, right? There we go. We got an integer back from... No, we got a string back from that integer, right? We wanted a string. The HP is an integer. We use the string function to get the string out of it. All right, so that should work now. I think what I'll have to do now is test the thumb drive. Head up your salty face. Just in time for Minecraft. You playing tonight, dude? Who's playing Minecraft with us? We had so much fun last time. Let's run the module. I'm going to be... the hero's going to be your salty face. And the villain is going to be K. Reich Jr. because he left us here. All right, let's try the potion now. All right, now it works. I healed myself. I didn't take any damage. That's fine. I'm going to try the thumb drive now. Oh, I'm sorry. I want to use item and then thumb drive. Okay. All right. So, it would appear to me that everything works. Let's try and finish the fight. Yeah, let's go Signap. That may be fun. If you can't make it, it's fine. I understand. People get busy sometimes. We can always, I can always entertain myself. I don't play Craft, but Python is hard-ass shit, though. Python's not that bad, you're salty. If you go back to our YouTube channel at youtube.com/Vencabot archive and go watch a previous season, you might find that it's actually easier than you think. If you start in episode 1, we kind of go back and talk to it, kind of explain Python as if you had never programmed before in your life. Right? We can kind of walk you into it. It's actually not that bad. It's pretty fun and even. Let's attack. Let's attack. And let's see here. So I'm pretty low on health, but I have the turn. I can kill him, right? How much attack power do I have? He has 5 HP left. What's my attack power? Can I kill him? Should I throw the spear to finish the job? The spear does double damage. I have 6 attack power anyway. I can kill him with just a normal attack. Let's do that. Oops. Let's do the spear anyway. Item, spear. Negative 10 damage. Overkill. Yeah, I'm victorious. So the program works, guys. The program works. Now, before I end the stream, I want to do one final enhancement. One final enhancement. As a way to make our code cleaner and also finally reiterate how dictionaries work. Right? Look down here. It says, if the player's choice is to attack, then run the turn attack function with the game state argument. If the player wants to defend, then run the turn defend function with the game state argument. And if they want to use an item, then run the turn item function with the game state argument. But what we can do instead, I realize it's going to be kind of hard to teach this right now. I'm going to do the same thing up here with the items instead, in the item area here. Right, so we say, you know, if they want to use a spear, right, then use item spear. If they want to use toilet paper, use this function, right? So basically we're saying here, if they typed in this, do this. If this, do this. If this, do this. Now what does that sound like? It sounds like, to me it sounds like a dictionary waiting to happen, right? We have this string, and it's associated with this thing. We have this string, and it's mapped to this thing, right? So why don't we, instead of doing this big long if block, why don't we say this? Why don't we say, you know, up here in our items, make a dictionary, right? In our item turn, make a dictionary. We're going to say here, item map equals spear gets mapped to this function item spear. Okay. Let's try I can do that. Can I do that? I think I can do that. If this doesn't work, we'll save it for next time, guys. We'll do roll of toilet paper. We're going to map that to the function item roll of toilet paper. Okay. We have, if they want to use the potion, we're going to map that to the function item potion. And then if they have, if they want to use this thumb drive, map that to the function item thumb drive. You can in JS. Yeah, I think because I'm defining them as, you know, a part of the global state, they should be okay for now. But I'm realizing now this might have been a bad idea to start at the very end of the stream here, because it might not be as clean as I would like. All right, so let's see here. So we have this map, right? The map is mapping these strings to these functions. Okay, and now we can say, instead of all these if blocks, why don't we just say, I'm going to actually comment this line out. We don't need this line anymore. We can talk about that later. Talk about error catching in our next stream, perhaps. We're going to say here, instead of all these ifs, we're going to say, just use our item map at the item they want to use, right? So whatever the user typed in, just use that as our key. And then run that function we get back using the game state argument. We're going to talk more about how this line works next time, guys. But basically we're saying here, we have a dictionary, and every string is mapped to a function. These are all functions, right? They might not actually end with this. Remember we talked before about how if you want to call a function, then you use these parentheses, right? That means you call the function. But you can refer to the function by its name. Right? We have this function, right? Item spear. And then we're calling it down here. So we're using, I'm going to actually make it a little more clear. We're going to call this item function. Is our item map at the key for a used item. So if I typed in the word spear, it gets saved here, right, to used item. Then we're going to say here, go to the item map, right, our dictionary up here, and find out what function is associated with that key. So here's spear, here's the function. We're going to save that as our item function. And now we can call our item function like this. We know it takes the game state, right? There we go. Now, like I was telling Rico, because of the way that globals work in Python, I'm not totally sure this is going to work. I'm going to comment this out for now. We don't actually have any more error catching if they type in the wrong thing. But we'll save that for next time. Let's see if this works at all. Run module. David, other David. I'm an egotist, right? Item. Let's try and use a spear. Okay, so spear does work. So they are globals. We'll fix that. We'll make it a little more overt later. Basically, what we're saying here, guys, is instead of using a big bunch of if statements saying, if this string, then do this thing, we're going to use a dictionary instead, right? We're saying map this function to this string, right? So if we use that string in our dictionary right here, we're going to get a function back, right? If the user typed in spear, right? In fact, we actually simplify this line. We're going to actually, no, let's not do that right now. So we're going to call this player choice, actually. Player choice is whatever they typed in, right? They typed in spear. We're going to save that as player choice. And then we're going to say, hey, whatever they typed in, use that as the key for our dictionary, right? And get a function out of it. And then use that function with the game state argument. There you go. Easy peasy. Good stuff yourselves. I hope you enjoy it. I tried doing the basic one on some coding website and couldn't do shit. I think it's probably a little bit easier if you have somebody talking to you rather than trying to read all that stuff in one big block. Sig says, I would watch your videos on coding, but I got so much school on my back. I've been getting so much homework. I'm sorry, dude. Well, work your way through it, man. Just power through. Yeah, I think we should be able to do this, DJ. I think everything's going to be working fine here. I might change. We're going to do more about that in our next stream on Friday, next Friday. We're going to do more with dictionaries and swapping out like this if block down here. Here's the problem, though, guys. Our problem with this code the way it is, we used to have this old code right here. I commented it out, right? So it's not going to run anymore. Before it used to be, if they typed in spear, then do this. If it was potion, do that. Else, otherwise, print off, so-and-so is not carrying that. With our current dictionary the way that it is, that's not going to work for us. In fact, if we try and type in a key that does not exist in that dictionary, right, we're going to say here, like, Cloud and Sephiroth. I want to use an item, right? If I type in the word spear, then it'll use what I type in as a key for this dictionary, right? It'll save player's choice as spear, then say, hey, listen, get me back whatever the dictionary has at spear, which would be this function, item spear, right here, the function, right? But the problem is, what if I type in something that's not a key in that dictionary? Is it going to say here, Cloud isn't carrying that like it used to? Probably not, right? Let's see what happens. I want to use, my Buster Sword on Cloud, right? I can do that. Oh, it crashed the whole fucking program. It says key error, Buster Sword. What's telling me is that I tried to get some data out of the dictionary that it did not have, and that will crash your program. Next time, guys, we're going to learn about how to deal with key error and other errors so that it doesn't crash your whole program, and then you can do all kinds of fun stuff. Actually get our old code, excuse me, I'll actually fix it right now. And we'll explain it more next time. I'm going to say here, try this. Right. I'm going to say here, except key error, print off you know, game state, protagonist name, plus isn't carrying that. All right, just like before. Then we're going to say else do this. Okay, so by adding a couple lines of code, we fixed that crash and added in new functionality to our program. Right now it's going to actually very neatly say that I don't carry that anymore. Let's try this out. So I'm going to run this Cloud versus Sephiroth. I'm going to use an item, so I'm going to have Buster Sword. And it says I'm not carrying that. Right? Cool beans. So we'll talk more about how that works next time, but basically we can use errors to our advantage. That's going to be kind of fun. But guys, it's been so much fun hanging out today. We learned so much really quickly. I apologize if I moved a bit too fast. Thankfully, go back to YouTube and do whatever. Watch the VOD on Twitch to review. We made a lot of progress. Our code is way cleaner now with a bunch of discrete functions instead of one big tower of code. It's not a bunch of individual functions that are easy to understand on their own piecemeal. Right? They're kind of divided up now by what they do instead of just being one big tower. That's kind of cool. We learned about how objects work, how dictionaries work, what mutability is, why some objects have to be returned from functions because they were made inside the function, whereas other things don't have to be returned at all because they were actually made outside of the function but only changed inside the function. That's a thing. We made all of our functions use the same argument, game state, which has its disadvantages maybe, but as you can see right here at the end of our stream, we made this item code really, really clean using a dictionary. Because we know that whatever item, whatever function we're calling uses this same argument. Because it's the same argument, it's very easy to swap them in and out seamlessly. So that's why we did that, guys. So we can use dictionaries to sort of organize our code a little bit better. Yeah, we just learned so much, guys. Our game, at the end of the day, works just like last time. Right? Actually, our game has no new features after 2 hours of hanging out and talking about programming. But what's really cool is that now it is much easier to add new features to. It's much easier to read because we've used more advanced concepts to make the code more elegant. And the more elegant your code is, the easier it'll be to make your games bigger and more exciting. I'm going to go over a short break, guys, and come right back with some Minecraft action. If you want to keep the channel online, you're enjoying it, check out patreon.com/Vencabot. Even $1 is a huge help there every month, guys. Helps me buy groceries and gas. I stream for 40 hours a week, every week. And when the stream ends, we're going to stream all night long, doing things like uploading to GitHub, posting videos on YouTube. It's a lot of work, but you guys make it a lot of fun here. And again, Patreon really helps out in terms of making it sustainable. If you're like me, you're not exactly rolling in dough, you can help for free in that case by giving the chat, come say hi, follow on Twitch, join us on Discord at vencabot.com, save clips of gameplay. Check out YouTube again at youtube.com/Vencabot Archive, or just search for VT on there, or excuse me, search for Vencabot on there. You will find me that way too. We have all kinds of cool gameplay videos. We have more than 1,000 videos on YouTube. A lot of those are programming and creative stuff. We also have, Third Strike, Street Fighter 3. We've got other retro games, long plays, online stuff. It's a lot of fun. I'll be right back, guys, with some Minecraft. I'll see you guys very shortly. Come play with us. We're playing on the Windows 10 version of Minecraft. If you guys have that, you're totally welcome to come play. Just let me know what your Xbox Live gamer tag is, and I will add you to my friends list, invite you to the world. It'll be easy peasy. But I'm really proud of what we accomplished today, guys. Again, feature-wise, it's exactly the same. Right? Feature-wise, it's exactly the same.
He has KO punch.
But internally, it is much more sensible.
Wait, what? How'd he get back?
It's so much easier now to add new commands, add new features, because it's broken up much more neatly. It's not as hard to go through and see what's up. Hey, good night, Rico. Thanks for stopping by, dude. You've been a pleasure in the chat, man. It's been awesome having you today. Have a good evening. Yeah, the stream's not over, guys. I'm just changing the shows here. We stream for 8 hours a night, 5 nights a week. And we're wrapping up Python, but we're starting with Minecraft in a few minutes. I'm glad you're enjoying it, Salty. Again, I feel like if you're intimidated by programming, then definitely work with me, man. If you want to join us on our programming, our larger projects, so we're trying a new series. We're trying a new series on the show, guys, where we're doing Intro to Python on Fridays, where it's like a tutorial, and it picks up every Friday where it left off, right, for 6 episodes.
Fucking Courtney Miller
but also,
combos, Kenny.
as a channel on Vencabot, we are making a game development studio. where I'm going to be working on a much larger project, a much larger game, much more involved experience for players. And a big part of that's going to be taking novices and teaching them programming so they can help out. Right, we're going to be kind of using it as a way to train people and empower people that are interested in game dev. And we can kind of all work together. Even if you've never programmed before in your life, I can walk you through it step by step. So, Salty, if you're interested at all, if you have free time, I know not everybody has that kind of free time, but if you're interested, I think you're on Discord already. Let me know on the game dev group channel on there, and me and you can work on programming together from the basics of stuff, the very, very basics. And I can train you to help us out. Or we can come back, like next month we'll be starting a new series here. A new series of Intro to Python where we go back to the very, very basics again. And go from scratch and work our way back up to this. This was episode 3, guys. Episode 3 means we've got a couple episodes already under our belt of the very, 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 very basics. By this point, we've gotten to some kind of complex stuff. Always a pleasure, Salty. Thanks for hanging out, Ming.